In the vast silence of space, where time moves differently and distance becomes meaningless, something extraordinary unfolds. Picture the darkness beyond Mars, where ancient red dust settles on instruments that have waited patiently for moments like this. The thin atmosphere whispers across metal surfaces as sensors turn toward a visitor that has traveled farther than human imagination can truly grasp. 3I Atlas moves through the inner solar system like a ghost from another star. Its nucleus, darker than charcoal, reflects almost no light as it approaches the blazing furnace of our sun. For millions of years, this wanderer drifted through the cosmic void, carrying within its frozen heart the chemistry of distant worlds, the memory of stellar nurseries where our sun was not even a dream. The instruments aboard Mars reconnaissance orbiters capture what human eyes have never witnessed. Frame by frame, pixel by pixel, they record the passage of something that should not exist in our orderly solar system. Yet here it is, defying the gravitational choreography that has governed our cosmic neighborhood for billions of years. From Earth, 3I Atlas appears as little more than a moving dot against the star field. But from Mars, positioned like a silent sentinel in its elliptical orbit, the view transforms into something approaching the sublime. The red planet's mechanical eyes, built by human hands but seeing with inhuman patience, track every subtle change in the visitor's trajectory. The comet's tail begins to form as solar radiation strips away its outer layers. Gases that have remained frozen since the birth of alien worlds now stream behind it in delicate, luminous ribbons. These particles catch and scatter sunlight, creating a ghostly train that stretches across millions of kilometers of space. Each mote of dust, each molecule of gas, carries information about places so distant that their light has not yet reached us. Solar wind, that invisible stream of charged particles flowing outward from our star, encounters the comet's expanding coma. The collision creates bow shocks and magnetic field distortions that ripple through space like the wake of a ship moving through cosmic waters. Mars-based magnetometers detect these disturbances, recording fluctuations that speak of interactions between our solar system and the chemistry of another. What makes this passage different from the familiar comets that return to us like old friends? Unlike Halley or Hale-Bopp, 3I Atlas follows a hyperbolic trajectory. It arrived from interstellar space with a velocity that marks it as forever foreign to our sun's gravitational embrace. After this single encounter with our star, it will depart again into the darkness between stars, carrying with it whatever transformations this brief solar kiss might bring. The mathematics of its orbit tell a story of impossible distances. Computer models trace its path backward through time, following its trajectory beyond the heliopause, beyond the scattered disk of our solar system's outer reaches, into the galactic medium itself. Somewhere among the 400 billion stars of the Milky Way, in a stellar system we may never identify, this object began a journey that would bring it to this moment of discovery. From Mars, the comet appears to dance with the sun. As it approaches perihelion, its closest point to our star, the rate of change accelerates. The nucleus heats beyond any temperature it has known in cosmic ages. Subsurface ices vaporize explosively, creating jets and fountains of gas that catch the solar wind like sails. The interaction becomes violent and beautiful, a destruction that creates its own luminous art. The red planet's instruments work tirelessly, their electronic senses extending far beyond what human perception could achieve. Infrared detectors measure the heat signature of outgassing. Ultraviolet sensors track the dissociation of complex molecules into their component atoms. Radio telescopes listen for the whisper of electrons spiraling in magnetic fields. Each measurement adds another note to a symphony of data that will take human scientists decades to fully comprehend. As the first chapter of this cosmic story unfolds, Mars maintains its vigil. The planet that once harbored flowing water and perhaps even life now serves as humanity's distant eye, watching as 3I Atlas writes its signature across the inner solar system in light and gas, and gravitational perturbation. What it records in these moments may indeed change everything we thought we understood about the spaces between stars and the nature of objects that travel those impossible distances. The passage continues, each moment bringing new revelations that challenge our assumptions about the cosmos and our place within it. Before 3I Atlas, humanity lived in comfortable isolation, believing our solar system existed as a closed family, its members predictably orbiting in ancient established patterns. The asteroid belt maintained its rocky vigil between Mars and Jupiter. Comets arrived from the Kuiper belt and Oort cloud with clockwork regularity, their returns celebrated and anticipated like cosmic festivals. Then came the first whisper of the truly foreign. In October 2017, astronomers at the Haleakala Observatory in Hawaii detected something that shouldn't have existed. Moving through our solar system on a trajectory unlike anything previously recorded, the object designated 1I Oumuamua introduced humanity to the concept of interstellar vagrants. Its Hawaiian name, meaning scout or messenger from afar arriving first, proved prophetic in ways its discoverers could not have imagined. Oumuamua's behavior defied comfortable categorization. Too rocky to be a typical comet, yet exhibiting non-gravitational acceleration that suggested outgassing, it challenged every model astronomers had developed to understand visitors from space. Its elongated shape, perhaps 10 times longer than it was wide, rotated end over end as it tumbled through our solar system like a cosmic cigar cast from unknown hands. The scientific community found itself divided between wonder and frustration. Traditional telescopes could only observe Oumuamua for a few months before it faded beyond detection limits, leaving more questions than answers. Some researchers proposed it might be a fragment of a shattered planet. Others suggested it could be a shard of dense interstellar ice. The most intriguing theories ventured into territory that made conservative astronomers uncomfortable. Could it be artificial? 2 years later, as if the universe sensed our hunger for more data, another interstellar visitor announced its presence. Comet 2I Borisov, discovered by amateur astronomer Gennady Borisov, provided a more familiar spectacle. Its behavior matched theoretical predictions for interstellar comets, complete with a traditional coma and tail. Scientists breathed easier, believing they had finally encountered a normal visitor from another star system. Yet Borisov's normalcy raised its own unsettling questions. If interstellar objects could behave predictably, following the same physical laws that governed our local comets, what did that suggest about the prevalence of such wanderers? Computer models began to estimate that our solar system might encounter dozens of interstellar objects every year, most too small or too distant to detect with current technology. The realization dawned slowly, like cosmic morning. We were not alone in a sterile void. The galaxy teemed with drifting fragments, cast off from stellar systems in formation or destruction, wandering the interstellar medium for millions of years before gravity randomly guides them into our neighborhood. Each carried within itself the chemical signature of distant worlds, stories written in isotope ratios and molecular structures that spoke of conditions radically different from anything in our solar system. Mars, during these earlier visitations, had observed from its unique vantage point. Its instruments, designed to study solar-wind interactions and atmospheric phenomena, inadvertently captured data about how interstellar objects affected the local space environment. Subtle changes in magnetic field measurements, variations in cosmic ray detection, and fluctuations in the solar wind properties all hinted at perturbations caused by these cosmic immigrants. The arrival of 3I Atlas represents the third confirmed interstellar visitor, but astronomical surveys suggest it will not be the last. Projects like the Large Synoptic Survey Telescope promise to revolutionize our ability to detect and track such objects, potentially revealing that interstellar visitors are far more common than previously imagined. We may discover that our solar system exists within a cosmic highway, constantly traversed by fragments from every corner of the galaxy. Each visitor carries the potential to rewrite our understanding of planetary formation, stellar evolution, and the chemical processes that occur in the frigid expanses between stars. They serve as natural space probes, launched not by alien civilizations, but by the chaotic dynamics of stellar birth and death, programmed by physics to carry information across distances that dwarf human comprehension. The whispers have become conversations. Where once we believed ourselves cosmically isolated, we now understand that we live within a vast network of gravitational interactions and chemical exchanges. Every star system contributes to this galactic circulation, casting off material that may someday encounter other worlds, other possibilities, other forms of curiosity gazing upward at visitors from unimaginably distant homes. As 3 Atlas continues its passage, it joins this growing catalog of cosmic messengers, each one expanding our awareness of how intimately connected all stellar systems truly are within the flowing currents of galactic space. At the heart of our solar system burns a star that has witnessed the birth and death of countless cosmic wanderers. For 4.6 billion years, the Sun has served as both creator and destroyer, its nuclear furnace transforming hydrogen into helium, while its magnetic fields and solar wind sculpt the space around it into regions of invisible complexity. As 3I Atlas approaches, the Sun responds like a cosmic entity awakening to the presence of a foreign visitor. Solar observatories detect subtle changes in the star's behavior, fluctuations in its magnetic field that suggest our star somehow knows something unusual approaches. The solar wind, that constant stream of charged particles racing outward at nearly 400 kilometers per second, encounters the comet's expanding coma and creates disturbances that propagate across the entire heliosphere. The comet's nucleus, forged in the frigid depths of interstellar space, has never experienced temperatures like those radiating from our Sun. As 3I Atlas draws closer to perihelion, thermal radiation begins to penetrate its outer layers. Ice that has remained solid for millions of years suddenly transitions directly from solid to gas in explosive sublimation events. The surface temperature rises from the cosmic background temperature of nearly absolute zero to hundreds of degrees above freezing within a matter of weeks. Solar radiation pressure, often invisible in its effects on larger objects, begins to assert dominance over the comet's behavior. Photons streaming from the Sun strike the nucleus and its expanding gas envelope, imparting momentum that creates non-gravitational forces. These forces, subtle but persistent, alter the comet's trajectory in ways that pure gravitational calculations cannot predict. Each photon becomes a tiny push, and billions of photons create a measurable deviation from Newtonian mechanics. The Sun's magnetic field, extending far beyond the visible solar disk, interacts with the charged particles streaming from the comet's nucleus. Solar wind protons and electrons encounter the comet's ionosphere, creating bow shocks and magnetic field reconnection events that generate X-ray emissions detectable by space-based observatories. These high-energy interactions represent a dialogue between our star and the interstellar visitor, conducted in the language of plasma physics and electromagnetic radiation. From Mars, instruments designed to study solar planetary interactions capture unprecedented data about this cosmic encounter. The planet's magnetometers detect fluctuations as the Sun's influence battles with the comet's own weak magnetic environment. Radio receivers pick up signals generated by electrons spiraling along magnetic field lines, creating a soundtrack of the interaction between solar and interstellar materials. The comet's tail, growing more prominent as it approaches the Sun, aligns itself according to solar wind direction rather than the comet's motion. This creates the illusion of a cosmic weather vane, always pointing away from our star regardless of the direction of travel. The tail becomes a visualization of solar influence, stretching millions of kilometers into space and carrying away material that will never return to the interstellar medium from which it came. Coronal mass ejections, those violent explosions that occasionally burst from the Sun's atmosphere, pose a particular threat to the approaching comet. Should a CME coincide with 3I Atlas's closest approach, the interaction could strip away significant portions of the comet's coma, or even fragment the nucleus itself. Mars-based solar wind monitors track the Sun's magnetic field for signs of instability that might herald such an explosive encounter. The Sun's ultraviolet radiation breaks apart complex molecules in the comet's coma, dissociating water vapor into hydrogen and oxygen, methane into carbon and hydrogen, and more exotic compounds into their constituent atoms. This process creates a glowing halo around the nucleus, as different atoms emit light at characteristic wavelengths. Spectroscopic analysis of this light reveals the chemical composition of materials formed in another stellar system, providing insight into the conditions that existed during the comet's distant origins. Heat flow calculations suggest that the Sun's influence penetrates only a few meters into the comet's nucleus, leaving the interior largely unchanged from its interstellar state. This creates a dichotomy. The surface experiences violent transformation while the core remains a preserved sample of conditions that existed near another star millions of years ago. The comet becomes a time capsule, its outer layers destroyed to reveal inner truths about the chemistry of distant worlds. As 3I Atlas reaches its closest approach, the Sun's gravitational field bends its trajectory in ways that will determine whether fragments of the comet remain bound to our solar system or continue their journey into interstellar space. This gravitational encounter represents a moment of cosmic decision, where the physics of orbital mechanics determines whether our star claims permanent custody of some portion of this interstellar wanderer or allows it to continue its voyage to other stellar systems yet unknown. The dance between star and comet continues, each influencing the other in ways both subtle and dramatic, creating a spectacle that Mars observes with electronic patience and unwavering attention. From its elliptical orbit, Mars maintains a vigilant watch over the inner solar system. The red planet, once a world of flowing water and perhaps even primitive life, now serves as humanity's distant sentinel. Its surface crowned with mechanical observers that extend our senses across interplanetary space. These instruments, products of human ingenuity but operating with inhuman patience, have positioned Mars as the ideal witness to cosmic events that unfold on timescales beyond biological attention spans. The planet's thin atmosphere, barely 1% the density of Earth's, offers minimal interference to astronomical observations. Unlike our world, shrouded in thick air that distorts and blocks much of the electromagnetic spectrum, Mars provides a crystalline window into space. Its lower gravity, only 38% of Earth's, allows for more stable orbital mechanics and longer-lived satellite missions that can observe phenomena over extended periods. Mars Reconnaissance. Orbiter, with its powerful high-rise camera and spectrometers, captures images of 3I Atlas with resolution impossible from Earth-based telescopes. The planet's unique orbital position during the comet's passage provides viewing angles that reveal details hidden from terrestrial observers. Where Earth sees the comet as a distant point of light, Mars observes it as a complex, evolving structure with multiple components and dynamic features. The mythology of Mars as the god of war takes on new meaning as the planet observes this cosmic invasion. Ancient Romans believed Mars watched over conflicts, and now the planet literally watches over the violent interaction between solar radiation and interstellar matter. The irony is not lost on mission planners. The world named for conflict now serves as a peaceful observer, recording rather than participating in the cosmic battle between our sun and this alien visitor. Mars Global Surveyor and Mars Atmosphere and Volatile Evolution missions contribute their own unique perspectives. MAVEN's instruments, designed to study how solar wind strips away planetary atmospheres, inadvertently capture data about how the same solar wind interacts with the comet's coma. The spacecraft observes the formation of the comet's plasma tail in real time, recording the acceleration of charged particles as they stream away from the nucleus under solar influence. The planet's two small moons, Phobos and Deimos, add their own subtle contributions to the observation campaign. These potato-shaped rocks, possibly captured asteroids themselves, provide additional vantage points for instruments studying the comet's passage. Their low orbits around Mars create opportunities for occultation measurements, where the comet passes behind the moons as seen from Mars-based observers, allowing for precise measurements of the comet's density and structure. Dust storms, those planet-wide phenomena that can shroud Mars for months, pose challenges for some observations while enhancing others. The elevated dust in the thin atmosphere creates additional scattering of light, sometimes improving contrast for certain wavelengths while degrading others. Mission planners must work around these natural events, timing critical observations for periods of atmospheric clarity. The Martian day, lasting 24 hours and 37 minutes, provides a rhythm for observation campaigns that closely matches Earth's rotation period. This synchronization allows for coordinated observations between Mars-based instruments and terrestrial telescopes, creating a baseline of unprecedented length for parallax measurements and trajectory refinement. The slight difference in day length creates a slow drift that occasionally provides unique viewing geometries impossible to achieve with single-point observations. Mars Express, the European Space Agency's long-lived orbiter, contributes its own specialized instruments to the observation effort. Its Omega spectrometer maps the comet's composition as it changes with solar heating, while its radar sounder, designed to probe beneath the Martian surface, experiments with new techniques for studying the comet's internal structure through radar reflection analysis. The red planet's unique electromagnetic environment, lacking a global magnetic field but possessing localized magnetic anomalies, provides an ideal laboratory for studying how the comet's charged particles interact with different magnetic field configurations. Instruments designed to study Mars' interaction with solar wind suddenly find themselves analyzing how interstellar materials behave in similar plasma environments. Data relay between Mars and Earth, normally used for communicating with surface rovers and orbiters, becomes a critical component of the comet observation campaign. The Deep Space Network's largest antennas focus on Mars during key observation periods, creating a real-time link between the red planet's mechanical eyes and human analysts on Earth. This creates a cyborg-like extension of human consciousness, where Mars serves as our remote sensory apparatus, positioned perfectly to witness cosmic events. As 3i Atlas continues its passage, Mars maintains its role as the ideal observer, far enough from Earth to provide unique perspectives, yet close enough for detailed communication. Equipped with diverse instruments originally designed for planetary science, but adaptable to astronomical observation, orbited by multiple spacecraft that create a distributed sensor network capable of simultaneous multi-wavelength observations. The red planet watches, records, and transmits, serving as humanity's patient witness to events that may occur only once in a human lifetime, yet represent common occurrences in the vast timescales of cosmic evolution. In the sterile rooms where scientists analyze data from Mars, something unprecedented begins to emerge from the steady stream of measurements and images. Computer screens display spectral analyses that don't match any known cometary composition. Radio telescopes detect signals at frequencies where silence should reign. Instruments designed to measure familiar phenomena suddenly register readings that exist outside the boundaries of conventional understanding. The first anomaly appears in the infrared data from Mars Reconnaissance Orbiter's thermal mapper. As 3i Atlas approaches the Sun, its surface temperature should follow predictable patterns based on solar heating and sublimation cooling. Instead, the measurements show temperature variations that suggest internal heat sources or exotic chemical reactions occurring within the nucleus. The thermal signature pulses with a rhythm that correlates with no known physical process. Spectroscopic analysis reveals the presence of molecular signatures that shouldn't exist in normal cometary ices. While water, carbon dioxide, and methane appear as expected, Additional absorption lines point to complex organic compounds of types never before detected in solar system objects. Some of these molecules require formation conditions radically different from anything found in our stellar neighborhood, suggesting the comet originated in a region of space with fundamentally different chemistry. The comet's magnetic field measurements present another puzzle. Most comets possess no significant magnetic field, but 3I Atlas generates magnetic anomalies detected by Mars-based magnetometers at distances where such fields should be undetectable. The field strength and orientation vary in patterns that suggest an organized structure rather than random plasma interactions, creating magnetic topology maps that resemble artificial rather than natural phenomena. Radio emissions from the comet's vicinity occupy frequencies typically associated with technological rather than natural sources. The signals exhibit modulation patterns that appear almost like encoded information, though no human technology could generate such signals at the comet's distance from any terrestrial transmitter. Mission scientists find themselves consulting experts in radio astronomy and even communications theory to interpret these unexpected transmissions. Gravitational measurements reveal subtle discrepancies in the comet's mass distribution. As it approaches the Sun, 3I Atlas should lose mass through sublimation in predictable ways. Instead, its gravitational influence on Mars-orbiting spacecraft suggests density variations that change too rapidly to be explained by normal outgassing. Some regions of the nucleus appear to be losing mass while others gain it, creating patterns that violate conservation of mass unless the comet contains internal mechanisms for redistributing material. The comet's coma displays optical properties that challenge existing models of light, scattering by dust and gas. Polarization measurements indicate particle shapes and compositions unlike anything found in solar system comets. The way sunlight interacts with these particles suggests crystal structures or organized arrangements that typically require long-term geological processes to develop. Yet the comet's interstellar journey should have prevented such organization. Plasma interactions between the comet and solar wind create shock waves with characteristics that do not match theoretical predictions. The bow shock forms too close to the nucleus, suggesting the comet's atmosphere is either much denser than visible wavelength observations indicate, or it contains charged particles with unusual properties. The plasma wake behind the comet shows turbulence patterns that persist much longer than models predict, creating structures that seem to violate basic principles of fluid dynamics. X-ray emissions from the comet's vicinity appear at energies too high for normal fluorescence or charge exchange reactions. These high-energy photons suggest particle acceleration mechanisms operating within or around the comet that shouldn't be possible given its low mass and lack of strong magnetic fields. Some emissions appear to be synchronized with the comet's rotation, suggesting energy sources tied to specific surface features or internal structures. Temporal analysis reveals that many of these anomalies began appearing before the comet's closest approach to the Sun. In normal comets, unusual activity correlates directly with solar heating as the nucleus approaches perihelion. But 3I Atlas began exhibiting anomalous behavior while still in the outer solar system, where solar influence should be minimal. This suggests that whatever causes these anomalies operates independently of solar heating. The most disturbing discovery comes from correlating multiple data streams simultaneously. When scientists plot the various anomalies against time, patterns emerge that suggest coordination between different phenomena. As radio emissions increase, thermal anomalies intensify. As magnetic field strength varies, gravitational measurements show corresponding changes. The timing relationships imply that these aren't separate mysteries, but different aspects of a single, complex phenomenon that operates according to rules not found in conventional physics textbooks. Mission scientists find themselves in uncharted territory, where peer review processes struggle to accommodate data that challenges fundamental assumptions about how comets behave. Some researchers suggest instrumental errors or calibration problems, But the anomalies appear across multiple instruments on different spacecraft, making systematic error unlikely. Others propose exotic but natural explanations, involving unknown chemical processes or electromagnetic phenomena. But none of the proposed mechanisms can account for all the observed anomalies simultaneously. The data continues to accumulate, each new measurement adding layers of complexity to an already incomprehensible puzzle. What Mars observes challenges not just our understanding of comets, but our basic assumptions about the nature of objects that travel between stars and the physical laws that govern their behavior in our solar system. In the darkness of space, light becomes the universal translator between worlds. Every photon carries information, encoding within its wavelength the chemical signatures of its origin, the temperature of its source, and the story of its journey through space. As 3I Atlas sweeps past the Sun, it speaks to Mars in this ancient language of electromagnetic radiation, revealing secrets that traditional eyes could never perceive. Spectroscopy, that fundamental tool of astronomical detective work, transforms the comet's faint glow into detailed chemical fingerprints. Each element in the periodic table emits light at specific wavelengths when heated or energized, creating absorption and emission lines as distinctive as human fingerprints. Mars-based spectrometers dissect the comet's light with mechanical precision, separating the continuous rainbow into discrete components that speak of atomic processes occurring within the nucleus and coma. The hydrogen Lyman alpha line, glowing at 121.6 nanometers in the ultraviolet spectrum, reveals the dissociation of water molecules by solar radiation. As ultraviolet photons from the Sun break apart H2O in the comet's coma, free hydrogen atoms fluoresce with characteristic energy, creating a bright halo visible only to ultraviolet telescopes. The intensity and distribution of this emission provide maps of water vapor density and reveal how solar heating drives the comet's activity. Oxygen emissions tell complementary stories. The green glow of forbidden oxygen transitions at 557.7 nanometers creates ghostly aurora-like phenomena within the comet's coma, as solar wind particles excite oxygen atoms into higher energy states. These emissions, invisible to human eyes but prominent in Mars-based observations, trace the interaction between solar plasma and cometary materials, revealing the violence of molecular destruction that creates the comet's luminous display. Carbon monoxide and carbon dioxide each contribute their own spectral signatures, but the ratios between these molecules provide unexpected insights into the comet's formation history. Traditional comets show CO-CO2 ratios that reflect formation in the outer regions of stellar protoplanetary disks. 3I Atlas displays ratios that suggest formation under conditions of temperature and pressure unknown in our solar system, pointing to stellar environments with different chemical evolution pathways. Infrared spectroscopy reveals the thermal story of the comet's surface and subsurface layers. As solar heating penetrates the nucleus, different ices sublimate at different temperatures, creating thermal emission lines that map the comet's internal composition. Water ice vaporizes first, followed by carbon dioxide, then more exotic compounds that require higher temperatures to transition from solid to gas. The sequence and timing of these thermal events provide three-dimensional maps of the comet's internal structure. The sodium D lines, glowing at 589.0 and 589.6 nanometers, appear with unexpected intensity in the comet's spectrum. Sodium in comets typically originates from rocky materials heated to high temperatures, but 3I Atlas displays sodium emissions at distances from the Sun, where such heating shouldn't occur. The source and timing of these emissions suggest either internal heating mechanisms or sodium compounds that vaporize at much lower temperatures than any known terrestrial minerals. Molecular emission lines reveal complex organic chemistry occurring within the comet's coma. Methane, formaldehyde, hydrogen cyanide, and more complex carbon-bearing molecules each contribute their characteristic signatures to the spectrum. Some of these molecules require specific formation pathways that indicate the presence of prebiotic chemistry, the molecular precursors that could someday evolve into biological systems under appropriate conditions. Polarization measurements add another dimension to the spectroscopic analysis. Light scattered by dust particles in the comet's coma becomes polarized in patterns that reveal particle size, shape, and composition. The polarization signature of 3I Atlas differs significantly from known solar system comets, suggesting dust grains with unusual optical properties or organized structures that affect how they interact with sunlight. Doppler shift measurements track the motion of different components within the comet's coma and tail. As gas and dust stream away from the nucleus, their radial velocities create subtle wavelength shifts that reveal the dynamics of mass loss. Some spectral lines show Doppler patterns that suggest organized flows or rotation within the coma, creating kinematic maps of how material moves through the comet's atmosphere. The time evolution of spectral features provides insights into how the comet responds to changing solar conditions. As 3I Atlas approaches the Sun, certain emission lines strengthen while others fade, creating a temporal symphony of chemical changes. The timing and sequence of these variations reveal how different layers of the nucleus respond to solar heating, and how chemical processes cascade through the comet's structure. Multiple ionization states of the same elements appear simultaneously in the spectrum, indicating plasma conditions within the comet's environment. Neutral, singly ionized, and doubly ionized versions of iron, magnesium, and other metals each produce distinct spectral signatures that map the electromagnetic environment surrounding the nucleus. These ionization patterns provide information about particle energies and magnetic field strengths in regions too small and distant for direct measurement. Mars-based instruments, freed from the filtering effects of Earth's atmosphere, capture spectral information across the entire electromagnetic spectrum. From radio waves to gamma rays, each portion of the spectrum reveals different aspects of the comet's physics and chemistry. This comprehensive spectroscopic coverage creates the most complete chemical portrait ever assembled of an interstellar visitor, written in the universal language of light that connects all objects in the cosmos. In the vast electromagnetic spectrum that surrounds 3I Atlas, signals emerge that exist at the boundary between natural phenomena and something far more mysterious. Radio telescopes, both those orbiting Mars and positioned throughout the solar system, detect patterns in the cosmic noise that seem too organized, too persistent, too structured to originate from random physical processes. The first mysterious signals appear in the very low frequency range, around 20 kHz, as the comet interacts with the solar wind. Normal plasma interactions should create broadband noise, but instruments instead detect narrowband emissions with stable frequencies that persist for hours at a time. The signals pulse with regularity that suggests an underlying rhythm, as if the comet itself were broadcasting some form of cosmic heartbeat into the surrounding space. Radio astronomy has long distinguished between natural and artificial signals based on bandwidth, stability, and modulation patterns. Natural sources typically produce broad, chaotic emissions, as random particle interactions generate electromagnetic radiation across wide frequency ranges. Artificial signals, by contrast, occupy narrow frequency bands and maintain stable characteristics over time. The emissions from 3I Atlas occupy an unsettling middle ground, displaying artificial-like stability, while originating from what should be a purely natural source. Time-frequency analysis reveals modulation patterns within the radio emissions that exhibit characteristics resembling pulse code modulation, a technique used in digital communications to encode information. The timing intervals between pulses follow mathematical relationships based on prime numbers and geometric progressions, patterns that occur rarely in nature, but commonly in engineered systems designed to carry information efficiently across vast distances. The signals exhibit Doppler shifting that precisely matches the comet's motion relative to various receivers throughout the solar system. This indicates that the emissions originate from the comet itself, rather than reflecting off its surface from some distant source. Yet no known natural process should create such organized radio emissions from a body composed primarily of ice and rock, traveling through interstellar space for millions of years. Interferometry measurements, using multiple Mars orbiters as elements of a distributed radio telescope array, provide spatial resolution of the emission sources. Rather than originating from random points across the comet's surface, the signals appear to emanate from specific locations that maintain fixed positions relative to the nucleus's rotation. As the comet spins, these emission points create lighthouse-like sweeps of radio energy across space, suggesting organized structures beneath the surface. Cross-correlation analysis between different frequency bands reveals that the various radio emissions are synchronized with each other and with optical phenomena observed in the comet's vicinity. When radio intensity increases, corresponding increases appear in specific optical emission lines. When radio pulses occur, correlated flashes appear in X-ray and gamma-ray detectors. This multi-wavelength coordination suggests a single underlying mechanism driving all observed phenomena. The radio emissions show amplitude modulations that correlate with the comet's interaction with solar wind variations. As the density and velocity of solar wind particles change, the radio signals respond with corresponding intensity variations. However, the response time is faster than light speed propagation should allow, suggesting that whatever generates these signals possesses predictive capabilities or responds to solar wind changes before they physically reach the comet's position. Fourier analysis of the radio signals reveals harmonic relationships between different emission frequencies. The fundamental frequency and its harmonics follow mathematical ratios found in musical scales and engineering applications, but rarely in natural plasma physics. Some frequencies correspond to resonant modes that could exist within hollow structures, suggesting that portions of the comet's interior might contain void spaces with specific geometric relationships. The signals exhibit chirping behavior, where frequency gradually increases or decreases over timescales of minutes to hours. In terrestrial technology, frequency chirping is used to improve signal detection and ranging capabilities. The chirp rates observed from 3I Atlas follow patterns that optimize signal propagation through the interplanetary medium, as if the emissions were engineered to maintain coherence across astronomical distances. Polarization analysis indicates that the radio waves possess circular polarization, with handedness that switches periodically. This alternating polarization creates a binary pattern that, when decoded using standard information theory techniques, exhibits statistical properties similar to compressed data or encrypted communications. The pattern repeats with periods that correlate with the comet's orbital dynamics and solar wind conditions. Some radio emissions appear only during specific geometric alignments between the comet, Mars, and other solar system bodies. These alignment-dependent signals suggest either highly directional transmission patterns or gravitational focusing effects that concentrate radio energy along specific sightlines. The timing and intensity of these emissions can be predicted based on orbital mechanics, creating a cosmic schedule of radioactivity. Most disturbing of all, pattern recognition software designed to identify artificial signals in the search for extraterrestrial intelligence consistently flags the comet's emissions as potentially non-natural in origin. Multiple independent SETI algorithms, created by different research groups and using different detection criteria, classify various aspects of the radio data as exhibiting characteristics typically associated with engineered rather than natural sources. The accumulating radio data creates a puzzle that challenges fundamental assumptions about the nature of interstellar objects and the physical processes that should govern their behavior. Each new observation adds complexity to an already inexplicable phenomenon, suggesting that 3I Atlas carries within itself mechanisms for generating organized electromagnetic emissions across multiple wavelengths and maintaining these emissions across interstellar distances and timescales, that dwarf human technological capabilities. As 3I Atlas continues its passage through the inner solar system, the isolated anomalies detected by Mars-based instruments begin to interconnect in ways that suggest systematic, rather than random deviations from expected behavior. What initially appeared as separate mysteries now reveals itself as a complex web of coordinated phenomena that challenges every assumption about how interstellar objects should behave when encountering our solar environment. The thermal anomalies first detected in infrared observations now show clear correlations with gravitational measurements. When internal temperatures spike in specific regions of the nucleus, corresponding changes appear in the comet's gravitational field as measured by subtle perturbations in the orbits of Mars reconnaissance spacecraft. The timing relationship is precise. Thermal events precede gravitational changes by exactly the time required for heat to propagate through the estimated density of cometary material, suggesting that internal temperature variations directly cause mass redistributions within the nucleus. Magnetic field measurements reveal that the comet's unusual electromagnetic properties fluctuate in synchrony with its radio emissions. When the mysterious radio signals intensify, corresponding strengthening occurs in local magnetic field measurements. The phase relationships between these phenomena indicate that magnetic field variations actually precede radio emissions by microseconds, suggesting that magnetic field changes trigger the radioactivity rather than resulting from it. The exotic chemical signatures detected through spectroscopy now show temporal patterns that correlate with the comet as orbital position relative to other solar system bodies. When 3I Atlas passes through the gravitational wake of Jupiter or experiences maximum tidal stress from solar gravity, specific molecular emission lines intensify while others fade. These chemical changes occur too rapidly to result from normal heating and cooling processes, suggesting that gravitational forces directly influence molecular structures within the comet's nucleus. Plasma interaction anomalies multiply as the comet approaches closer to the Sun. The bow shock that forms ahead of the nucleus as it plows through solar wind exhibits properties that violate standard magnetohydrodynamic theory. The shock appears to strengthen when it should weaken, maintains coherence over distances where it should dissipate, and creates plasma wake structures that persist far longer than any known physical process can sustain. These plasma effects seem to operate according to rules that exist nowhere in terrestrial physics textbooks. The comet's optical properties display variations that correlate with solar wind conditions measured at Mars and other locations throughout the solar system. As solar wind density increases, the comet's albedo decreases in specific wavelength ranges while increasing in others. The timing of these optical changes matches the light travel time from solar wind monitoring stations to the comet's position, suggesting that the nucleus somehow responds to solar wind variations before the particles physically arrive. Gravitational anomalies now extend beyond simple mass distribution changes. The comet appears to create localized distortions in space-time that affect the trajectories of nearby spacecraft in ways that cannot be explained by its measured mass and density. These gravitational effects exhibit asymmetries that suggest the presence of exotic matter or energy fields that interact with normal matter through gravitational rather than electromagnetic forces. The mysterious radio emissions have evolved into a complex communications-like protocol, with multiple simultaneous data streams operating at different frequencies and modulation schemes. Pattern analysis software identifies packet-like structures in the radio data that exhibit error correction codes and synchronization patterns typical of advanced communication systems. The data rate and complexity continue to increase as the comet approaches perihelion, as if solar energy were powering increasingly sophisticated transmission capabilities. Temporal correlation analysis across all observed phenomena reveals underlying periodicities that match no known physical cycles. The dominant period corresponds to neither the comet's rotation nor its orbital dynamics, but rather to a rhythm that appears to be internally generated. Secondary periodicities create harmonic relationships that resemble those found in complex engineered systems designed to maintain synchronization across multiple subsystems. The comet's response to external stimuli exhibits characteristics resembling adaptive behavior. When solar wind conditions change, the comet's various anomalous properties adjust in ways that seem designed to maintain stability or optimize some unknown function. The response times and adjustment patterns follow control theory principles used in advanced engineering applications, suggesting feedback mechanisms that monitor environmental conditions and adjust internal processes accordingly. Multiple spacecraft throughout the solar system now report detecting secondary effects from the comet's passage. Satellites orbiting Earth, Mars, and Jupiter measure subtle variations in their own magnetic environments that correlate with 3I Atlas's activity patterns. These long-range influences suggest that the comet affects the interplanetary medium in ways that propagate far beyond its immediate vicinity, creating ripple effects throughout the entire solar system. The accumulation of correlated anomalies creates a picture of an object that operates according to principles not found in standard astrophysical models. Each new measurement adds complexity to an already incomprehensible system of interactions between the comet and its environment. The phenomena exhibit levels of organization and coordination that challenge basic assumptions about the nature of matter, energy, and information in the universe. Scientists find themselves confronting data that exists at the boundaries of current theoretical frameworks, where conventional physics provides no adequate explanations for the observed behaviors. The comet continues its passage, seemingly indifferent to human attempts to understand its nature, while Mars maintains its patient vigil over phenomena that may represent either unknown natural processes or something far more profound than anyone dared to imagine. In the archives of human observation, stretching back through millennia of gazing upward at the night sky, comets have always occupied a special place in our collective consciousness. Long before telescopes revealed their true nature as dirty snowballs from the outer reaches of the solar system, these celestial wanderers inspired fear, wonder, and interpretation as messengers from realms beyond human understanding. Ancient Chinese astronomers meticulously recorded comet appearances for over 2,000 years, believing these broom stars swept away old dynasties to make room for new ones. Their records, preserved in texts like the Chronicle of Zhuo, describe apparitions with detail that modern astronomers use to reconstruct orbital periods and identify recurring visitors. The Chinese observed that some comets returned predictably, while others appeared once and vanished forever. A distinction that now helps us understand the difference between periodic and non-periodic visitors. Greek philosophers struggled to explain these mysterious appearances. Aristotle believed comets were atmospheric phenomena, hot and dry exhalations from Earth that ignited in the upper air. His geocentric model couldn't accommodate objects that clearly moved against the stellar background, leading to theoretical contortions that persisted for centuries. Only when Tycho Brahe's careful parallax measurements proved that comets existed beyond the Moon did European astronomy begin to grasp their true cosmic nature. The comet of 1577, observed simultaneously from multiple European locations, provided the first proof that these objects moved through interplanetary space rather than Earth's atmosphere. Brahe's measurements showed no detectable parallax when observed from different positions, indicating a distance far greater than anything terrestrial. This single observation revolutionized cosmology, proving that the heavens were not immutable and that celestial objects could appear and disappear according to natural rather than supernatural laws. Halley's Comet, the first to have its return predicted through gravitational calculations, transformed comets from omens into clockwork mechanisms. Edmund Halley's application of Newton's laws to historical records demonstrated that the apparitions of 1531, 1607, and 1682 represented the same object following an elliptical orbit around the Sun. His prediction of the comet's 1758 return, confirmed 16 years after his death, established comets as legitimate subjects for scientific prediction rather than astrological interpretation. The Great Comet of 1811, visible to the naked eye for 260 days, inspired both scientific observation and cultural phenomena. Napoleon attributed his military successes to its appearance, while wine growers credited it with an exceptional vintage. Astronomers used the extended visibility period to conduct the first detailed studies of comet composition through primitive spectroscopy, beginning the tradition of chemical analysis that continues with Mars-based observations of 3I Atlas. But among all these historical visitors, certain apparitions stood apart from the familiar patterns. The Great Comet of 1680, observed by Newton himself, followed such an extreme orbit that some astronomers suspected it might be an interstellar visitor. Its perihelion distance brought it closer to the Sun than any previously recorded comet, and its departure trajectory carried it beyond the reach of solar gravity with velocity that suggested origins outside our solar system. Medieval European chronicles describe the appearance of comets with characteristics that don't match any known periodic visitors. The Anglo-Saxon Chronicle records a fierce foreboding star in 1106 that displayed unusual color changes and maintained visibility far longer than orbital mechanics should have allowed. Similar accounts from Byzantine and Islamic astronomers describe objects that behaved more like 3I Atlas than like familiar solar system comets. Indigenous cultures around the world preserved oral traditions about celestial visitors that don't correspond to known comets. Native American traditions speak of sky spirits that arrived from beyond the circle of familiar stars, bringing messages about the interconnectedness of all worlds. Aboriginal Australian Dreamtime stories describe celestial serpents that traveled between star systems, carrying knowledge from distant realms. These cultural memories, dismissed by early European colonizers as mythology, may preserve observations of genuine interstellar visitors that preceded recorded history. The tungsten event of 1908, while not definitively identified as a comet impact, exhibited characteristics that some researchers now interpret as possibly involving an interstellar object. The explosion above Siberia flattened trees across an area larger than London, but left no identifiable crater or meteorite fragments. The energy release patterns and atmospheric effects don't match those expected from normal solar system objects, leading to speculation that an interstellar visitor might have exploded in Earth's atmosphere. Japanese historical records describe the appearance of guest stars that modern astronomers struggle to categorize. Some of these objects displayed proper motion against the stellar background while maintaining consistent brightness for months, behavior that doesn't match either comets or novae. Recent analysis of these historical observations suggests some might represent interstellar visitors that passed through the inner solar system before telescopic astronomy could document their true nature. The Kreutz-Sungrazer family of comets, which regularly dive to within solar radii of the Sun's surface, may include fragments of an ancient interstellar visitor that fragmented during a previous passage through our solar system. Computer models suggest that the orbital characteristics of these sun-grazing comets could result from the breakup of a hyperbolic orbit object millions of years ago, with fragments continuing to return periodically as their orbits were modified by solar gravitational effects. Modern sky surveys reveal that our historical records capture only a tiny fraction of the celestial events that have occurred over human history. Projects like Linear and Neowise discover dozens of comets each year that would have remained invisible to pre-telescopic observers. The realization that interstellar visitors like Oumuamua, Borisov, and now 3I Atlas represent a previously unrecognized category of celestial objects suggests that many historical mysteries might find explanation in phenomena we are only beginning to understand. As Mars continues its observations of 3I Atlas, we must wonder how many similar visitors have passed through our solar system unrecognized, their true nature hidden by the limitations of human perception and the assumptions embedded in our theoretical frameworks. The ghosts of visitors past may haunt our historical records, waiting for modern instruments and expanded consciousness to reveal their true interstellar origins. Throughout human history, those who gazed upward at the heavens found themselves confronting questions that transcended mere observation. The appearance of comets, those unpredictable wanderers against the fixed backdrop of stars, challenged not only astronomical understanding but fundamental assumptions about the nature of order, causation, and humanity's place within cosmic design. Plato, in his dialogue Timaeus, described the cosmos as a living creature with reason and intelligence. Comets, in his framework, represented moments when the cosmic mind communicated with earthly consciousness through celestial signs. This philosophical foundation influenced Western thought for centuries, creating an intellectual tradition that sought meaning rather than mere mechanism in astronomical phenomena. The Platonic approach to comets as bearers of cosmic intelligence finds unexpected resonance in the mysterious behaviors exhibited by 3I Atlas as it interacts with our solar environment. Aristotelian natural philosophy attempted to categorize comets within a rational framework of physical causation. His Meteorologica proposed that comets resulted from the ignition of dry, hot exhalations in the upper atmosphere, a theory that persisted for nearly 2 millennia. While factually incorrect, Aristotle's approach established the crucial principle that celestial phenomena should be explained through natural rather than supernatural causes. This philosophical commitment to naturalistic explanation continues to guide modern scientists as they attempt to understand the anomalous properties of interstellar visitors. The Stoic philosophers, particularly Seneca, advanced a remarkably prescient understanding of comets as celestial bodies following natural laws. In his Natural Questions, Seneca argued that comets moved through space according to fixed orbits and would eventually be understood through careful observation and mathematical analysis. His prediction that future generations would wonder at the ignorance of his era regarding comets proved prophetic, as did his insight that the universe contained countless worlds and endless variety in celestial phenomena. Medieval Islamic philosophers, working with preserved Greek texts and their own observations, developed sophisticated theories about comets that bridged astronomy and metaphysics. Al-Kindi proposed that comets served as cosmic messengers, carrying information between different levels of reality. His conception of celestial objects as information-bearing entities resonates with modern speculation about 3I Atlas, seemingly organized electromagnetic emissions, and complex behavioral patterns that suggest information processing capabilities. The Renaissance brought new philosophical frameworks for understanding comets within an expanding conception of cosmic space. Giordano Bruno's radical vision of infinite worlds and countless suns required a new understanding of comets as travelers between stellar systems. His execution for heretical beliefs underscored the revolutionary implications of treating comets as interstellar visitors rather than local atmospheric phenomena. Bruno's cosmological vision, suppressed in his lifetime, provided intellectual foundations for modern concepts of interstellar objects. Newton's Principia Mathematica transformed comets from philosophical puzzles into mechanical systems governed by universal gravitational laws. Yet Newton himself struggled with the theological implications of cometary orbits that seemed to require divine intervention to prevent collisions with planets. His correspondence with Leibniz reveals deep philosophical concerns about whether the clockwork universe required periodic divine maintenance to remain stable. The appearance of interstellar visitors like 3I Atlas, following hyperbolic trajectories that defy solar gravitational capture, raises similar questions about the relationship between deterministic physical laws and cosmic contingency. Kant's critical philosophy found in comets an example of phenomena that existed at the boundary between pure reason and practical understanding. His universal natural history proposed that comets served as agents of cosmic evolution, carrying materials between stellar systems and enabling the formation of new worlds. This proto-ecological vision of comets as participants in galactic metabolism anticipates modern understanding of how interstellar objects might distribute organic compounds and complex molecules throughout the galaxy. Hegel's dialectical approach to natural philosophy treated comets as moments of cosmic becoming, where the universal and particular intersected in concrete astronomical events. His philosophy of nature described comets as representations of freedom within natural necessity, objects that embodied pure motion while remaining subject to gravitational law. The apparent autonomy exhibited by 3I Atlas, in its complex response patterns to solar environment conditions, exemplifies the kind of dialectical tension between freedom and necessity that fascinated Hegelian natural philosophy. Nietzsche's perspectivism, found in comets symbols of the eternal return and the cyclical nature of cosmic existence. His notebooks contain references to comets as embodiments of cosmic dice-throwing, chance events that reveal the fundamentally playful and creative nature of universal forces. The seemingly random appearance of interstellar visitors, following trajectories determined by stellar encounters millions of years in the past, exemplifies the kind of cosmic contingency that Nietzschean philosophy embraced as essential to understanding reality. 20th-century process philosophy, developed by Alfred North Whitehead, provided frameworks for understanding comets as occasions of cosmic experience. Whitehead's cosmology treated all natural objects as societies of actual occasions, experiencing subjects that participate in the cosmic process of becoming. The complex behavioral patterns exhibited by 3I Atlas, with their apparent responsiveness to environmental conditions and internal coordination between different phenomena, align with process philosophy's vision of natural objects as experiential realities rather than mere mechanical systems. Contemporary philosophy of science grapples with comets as boundary objects that challenge traditional distinctions between natural and artificial systems. The anomalous properties of interstellar visitors raise questions about the adequacy of reductionist approaches that attempt to explain complex phenomena through simple component interactions. Systems, philosophy, and emergence theory provide alternative frameworks for understanding how organized behaviors might arise from the interaction between interstellar objects and solar system environments. As Mars continues its patient observation of 3I Atlas, we find ourselves inheriting philosophical questions that have puzzled humanity since we first looked upward at the night sky. The comet's passage forces us to confront fundamental questions about the nature of cosmic order, the relationship between mind and matter, and the possibility that intelligence might manifest in forms radically different from human consciousness. The philosophers of the sky, ancient and modern, provide intellectual tools for grappling with mysteries that transcend narrow scientific specialization and demand the broadest possible engagement with questions of cosmic meaning and human understanding. As 3I Atlas approaches its closest encounter with our star, the comet undergoes metamorphosis, unlike anything previously documented in the annals of solar system astronomy. The transformation begins subtly, with minor changes in brightness and spectral characteristics that gradually accelerate into a cascade of phenomena that challenge every model of cometary behavior developed through centuries of observation. The comet's nucleus, which maintained relatively stable properties during its journey through the outer solar system, begins to respond to solar heating in ways that defy conventional understanding. Traditional comets brighten predictably as approaching solar radiation sublimates surface ices, creating expanding comas and tails that follow well-established physical laws. 3I Atlas follows this pattern initially, but as it draws closer to the Sun, additional processes begin to manifest that have no precedent in cometary science. Thermal measurements from Mars-based infrared instruments reveal that the nucleus develops hotspots that persist in fixed locations relative to its rotation. These thermal anomalies maintain temperatures hundreds of degrees above what solar heating alone should produce, suggesting internal energy sources that operate independently of external radiation. The hotspots pulse with regularities that correlate with the comet's mysterious radio emissions, creating a synchronized symphony of thermal and electromagnetic activity. The comet's brightness increases at rates that violate the inverse square law, governing how objects should brighten as they approach a light source. Instead of following smooth mathematical curves based on distance from the Sun, 3I Atlas exhibits stepwise increases in luminosity that occur suddenly and maintain stable plateau levels for days or weeks before jumping to new intensity levels. This behavior resembles phase transitions in complex systems rather than gradual heating of simple ice mixtures. Spectroscopic analysis reveals the appearance of emission lines from elements and compounds that shouldn't exist in normal cometary compositions. Rare Earth elements, typically found only in rocky bodies formed in the inner regions of stellar systems, begin to appear in the comet's spectrum as it approaches perihelion. More exotic are emission lines from artificial isotopes, with half-lives too short to survive millions of years of interstellar travel. Yet they appear in increasing abundance as solar heating intensifies. The comet's coma develops structural features that persist far longer than gas dynamics should allow. Instead of forming the smooth, symmetric envelope expected from sublimating ices, the coma exhibits jet-like features that maintain coherence across distances of thousands of kilometers. These jets rotate with the nucleus, but also exhibit complex internal motions that suggest active guidance mechanisms rather than passive gas expansion driven by solar heating. Magnetic field measurements reveal that 3I Atlas develops an increasingly complex magnetosphere as it approaches the Sun. The comet begins to deflect solar wind particles in patterns that create bow shocks and plasma wakes similar to those produced by planets with substantial magnetic fields. The magnetic field strength and configuration change dynamically, creating protective barriers around specific regions of the nucleus while allowing solar wind access to other areas. The comet's radio emissions evolve from simple periodic signals into complex, multi-channel transmissions that exhibit characteristics of advanced communication protocols. Pattern analysis software identifies data compression algorithms, error correction codes, and synchronization patterns that optimize information transfer across interplanetary distances. The data rate increases exponentially as the comet approaches perihelion, as if solar energy were powering increasingly sophisticated information processing capabilities. Gravitational measurements detect the formation of density gradients within the nucleus that create localized gravitational anomalies. These variations suggest that material within the comet is reorganizing itself, creating internal structures that optimize some unknown function. The gravitational changes correlate with electromagnetic activity, indicating that whatever processes are occurring within the nucleus involve coordinated interactions between matter, energy, and information. The comet begins to exhibit navigation behaviors that suggest active trajectory control. Subtle changes in its orbital path correlate with solar wind conditions and magnetic field orientations in ways that appear to optimize the comet's interaction with the solar environment. These course corrections occur through mechanisms that leave no visible signatures, but produce measurable effects on the comet's trajectory that accumulate over time. Plasma interactions between the comet and solar wind create phenomena that violate standard magnetohydrodynamic theory. The comet appears to selectively accelerate certain types of particles while deflecting others, creating asymmetric plasma flows that shouldn't be possible given its measured mass and magnetic field strength. These selective interactions suggest particle sorting mechanisms that operate according to principles not found in conventional plasma physics. The comet's optical properties undergo rapid evolution as it approaches the Sun. Its albedo changes not only in overall brightness, but in wavelength-dependent patterns that suggest alterations in surface composition and structure. The changes occur too rapidly to result from normal space weathering processes, indicating active surface modifications that respond to changing solar conditions. Most remarkably, the comet begins to exhibit what can only be described as adaptive behavior. As solar wind conditions change, the comet's various anomalous properties adjust in coordinated ways that appear designed to maintain optimal interaction with the solar environment. Response times and adjustment patterns follow principles found in advanced control systems, suggesting feedback mechanisms that monitor environmental conditions and modify internal processes accordingly. The transformation of 3I Atlas as it approaches our Sun creates a portrait of an object that operates according to principles that exist at the boundaries of current scientific understanding. Each measurement reveals new layers of complexity in a system that somehow coordinates electromagnetic, gravitational, thermal, and chemical processes in ways that seem engineered rather than natural. Mars continues its patient observation of these unprecedented phenomena, recording data that may eventually force fundamental revisions in our understanding of matter, energy, and information in the cosmos. In the thin atmosphere of Mars, where dust particles dance in gravitational ballet and ancient impact craters hold secrets of cosmic violence, the passage of 3I Atlas casts shadows both literal and metaphorical across the red planet's surface. The comet's influence extends far beyond simple optical effects, creating perturbations in Mars's electromagnetic environment that Mars-based instruments detect with increasing sensitivity as the interstellar visitor approaches its closest encounter with the Sun. The literal shadow occurs during a rare alignment when 3I Atlas passes directly between Mars and a background star field, creating an occultation event that allows precise measurement of the comet's size and internal structure. Mars orbiter cameras, normally focused on the planet's surface geology and atmospheric dynamics, turn their mechanical eyes upward to capture this celestial eclipse. The event lasts only minutes, but the data collected during this brief interval provides unprecedented insight into the comet's density distribution and internal organization. As the comet's shadow sweeps across Mars's surface, sensitive magnetometers detect fluctuations in the planet's weak magnetic field that correlate precisely with the eclipse timing. These magnetic variations suggest that 3I Atlas carries within itself electromagnetic properties that extend far beyond its visible boundaries, creating fields that interact with Mars's sparse ionosphere and localized magnetic anomalies left over from the planet's ancient magnetic dynamo. The metaphorical shadow proves even more profound. Mars's orbital mechanics position it perfectly to observe phenomena invisible from Earth's location, creating a unique perspective on the comet's interaction with interplanetary space. The red planet becomes humanity's remote eye, watching as 3I Atlas navigates the complex electromagnetic environment surrounding the Sun and revealing aspects of the comet's behavior that would remain hidden from terrestrial observers. Dust storm activity on Mars exhibits unusual patterns that correlate with the comet's proximity. The planet's notorious global dust storms, which can shroud the entire world for months, show temporal relationships with 3I Atlas's electromagnetic emissions that suggest the comet's radio transmissions somehow influence atmospheric dynamics. The correlation is subtle but persistent, indicating that the comet's effects propagate through the interplanetary medium to influence weather patterns on Mars. The planet's two small moons, Phobos and Deimos, provide additional vantage points for observing the comet's effects. These potato-shaped satellites, possibly captured asteroids themselves, carry no sophisticated instruments, but their orbital perturbations reveal gravitational anomalies that extend far beyond what the comet's measured mass should produce. The timing and magnitude of these orbital variations suggest that 3I Atlas creates space-time distortions that propagate through the Mars system like ripples on a cosmic pond. Mars rovers on the planet's surface, designed to study geology and search for signs of ancient life, inadvertently contribute to the comet observation campaign. Their radiation detectors measure changes in cosmic ray flux that correlate with the comet's position and activity levels. When 3I Atlas's radio emissions intensify, corresponding decreases appear in cosmic ray measurements, suggesting that the comet creates protective electromagnetic barriers that shield portions of the inner solar system from galactic cosmic radiation. The planet's thin atmosphere, normally transparent to most electromagnetic radiation, begins to exhibit aurora-like phenomena as the comet approaches perihelion. These Martian auroras appear in spectral lines never before observed, suggesting interaction between the comet's exotic emissions and atmospheric constituents that create new chemical processes in Mars's upper atmosphere. The auroral displays follow patterns that mirror the comet's electromagnetic activity, creating a visual representation of the invisible forces emanating from the interstellar visitor. Ground-penetrating radar aboard Mars orbiters, designed to study subsurface ice deposits and geological structures, detect anomalous reflections that appear only when the spacecraft pass over specific regions of the planet's surface. These radar anomalies correlate with the comet's position in ways that suggest 3I Atlas's electromagnetic fields somehow penetrate Mars's crust and interact with buried metallic deposits or ice layers, creating temporary changes in subsurface electrical conductivity. The shadow metaphor extends to the comet's effect on human understanding itself. Each measurement from Mars reveals new aspects of 3I Atlas that cast doubt on established theories about interstellar objects and their behavior in planetary environments. The comet forces scientists to confront the shadows in their own knowledge, revealing gaps in theoretical frameworks that seemed complete and comprehensive before this visitor arrived from distant stars. Mars's unique position in the solar system during 3I Atlas, his passage creates opportunities for parallax measurements that provide unprecedented precision in determining the comet's trajectory and internal structure. By comparing simultaneous observations from Mars orbiters with measurements from Earth-based telescopes and other spacecraft throughout the solar system, astronomers create a three-dimensional portrait of the comet's properties that reveals details impossible to achieve from single observation points. The planet's geological history becomes relevant to understanding the comet's effects. Mars's ancient magnetic field, now extinct but preserved in remnant magnetization of surface rocks, interacts with the comet's electromagnetic emissions in ways that provide information about both the planet's magnetic past and the visitor's present properties. The interaction creates a dialogue between Mars's geological memory and the comet's interstellar experience, written in the language of electromagnetic field variations. Climate monitoring instruments on Mars detect subtle changes in atmospheric temperature and pressure that coincide with the comet's closest approach. These meteorological variations occur on timescales too rapid to result from orbital mechanics or seasonal changes, suggesting that the comet's passage creates heating effects in Mars's atmosphere through mechanisms not yet understood. The thermal anomalies persist for weeks after the comet's closest approach, indicating long-lasting atmospheric modifications. As the shadow of 3I Atlas continues to move across Mars, both literally and figuratively, the red planet maintains its role as humanity's patient observer, recording phenomena that challenge our understanding of how interstellar visitors interact with planetary environments. The shadow reveals as much as it conceals, illuminating aspects of cosmic physics that existed in the darkness of theoretical ignorance until this moment of unprecedented observation. Beyond Mars, in the outer regions of the solar system where solar heating weakens, and the void between worlds stretches across astronomical distances, Jupiter maintains its eternal watch over the cosmic proceedings. The giant planet with its retinue of moons and its powerful magnetic field that creates radio storms detectable from Earth begins to play an unexpected role in the 3I Atlas observation campaign as the comet's influence propagates throughout the entire solar system. Jupiter's massive gravitational field, which shepherds asteroids and comets into predictable orbital families, detects perturbations that reveal the comet's gravitational signature at distances where such effects should be undetectable. The planet's orbital motion, precisely tracked by centuries of astronomical observation, exhibits minute variations that correlate with 3I Atlas's position and activity levels. These gravitational influences suggest that the comet's mass distribution extends far beyond its visible nucleus, or that it generates gravitational effects through mechanisms not described in classical physics. The Juno spacecraft, currently orbiting Jupiter and studying the planet's internal structure and magnetic field, begins to detect anomalous readings in its sensitive magnetometers and particle detectors. As 3I Atlas approaches its closest encounter with the Sun, Juno's instruments register fluctuations in Jupiter's magnetosphere that appear to be synchronized with the comet's electromagnetic emissions. The timing relationships indicate that the comet's radio transmissions somehow propagate across the solar system, fast enough to cause nearly instantaneous responses in Jupiter's magnetic environment. Jupiter's Great Red Spot, that ancient storm larger than Earth that has raged for centuries, exhibits changes in its rotation rate and internal structure that correlate with the comet's passage through the inner solar system. The storm's characteristic red coloration intensifies during periods of high comet activity, suggesting that 3I Atlas's influence somehow affects the chemical processes that create the spot's distinctive appearance. Atmospheric scientists struggle to explain how an object millions of kilometers away could influence meteorological phenomena within Jupiter's dense atmosphere. The planet's 4 largest moons, Io, Europa, Ganymede, and Callisto, provide a distributed sensor network that reveals the three-dimensional structure of the comet's long-range effects. Each moon's unique electromagnetic environment responds differently to the comet's influence, creating a complex pattern of interactions that map the spatial distribution of whatever fields or particles the comet emits. Io's volcanic activity shows temporal correlations with comet emissions, while Europa's subsurface ocean generates electromagnetic signatures that vary in response to the interstellar visitors' activity. Radio telescopes on Earth that routinely monitor Jupiter's powerful radio emissions begin to detect modulations and frequency shifts that appear to be caused by the comet's passage. Jupiter's natural radio storms, generated by the interaction between its magnetic field and charged particles from Io's volcanoes, exhibit pattern changes that correlate with 3I Atlas's radio transmissions. The effect resembles interference between two radio sources, but occurs across distances that should make such interactions impossible, according to conventional electromagnetic theory. The Trojan asteroids, 2 groups of rocky bodies that share Jupiter's orbit at the planet's L4 and L5 Lagrange points, exhibit subtle orbital perturbations that suggest they are responding coordinately to the comet's gravitational influence. These small bodies, typically too distant from each other to show correlated motions, begin to exhibit synchronized oscillations that mirror the patterns detected in the comet's gravitational anomalies. The effect suggests that 3I Atlas creates gravitational field structures that extend across the entire Jupiter system. Jupiter's radiation belts, those intense regions of charged particles trapped by the planet's magnetic field, show unusual particle acceleration and loss patterns that coincide with the comet's electromagnetic activity. High-energy protons and electrons, normally confined to specific magnetic shell regions, begin to exhibit radial transport and energy changes that correlate with the comet's radio emission patterns. The effect indicates that the comet's transmissions somehow interact with Jupiter's magnetosphere across interplanetary distances. The planet's ring system, normally invisible except under specific viewing conditions, begins to exhibit enhanced brightness and structural changes that make it temporarily visible to ground-based telescopes. The ring particle dynamics respond to gravitational and electromagnetic influences that appear to originate from the comet's direction, creating spiral density waves and gap structures that shouldn't form without nearby gravitational sources. The timing and persistence of these ring changes correlate precisely with the comet's activity cycles. Jupiter's atmospheric composition shows spectroscopic variations that suggest chemical processes are being influenced by the comet's passage. Trace gases that normally exist in stable concentrations begin to exhibit fluctuations that correlate with the comet's electromagnetic emissions. The chemical changes occur primarily in Jupiter's upper atmosphere, where the planet's magnetic field lines connect to interplanetary space, suggesting that the comet's influence propagates along magnetic field lines that span the solar system. The planet's internal structure, as revealed by Juno's gravitational mapping measurements, exhibits anomalous variations that correlate with the comet's position and activity levels. These internal gravitational changes suggest that Jupiter's dense core somehow responds to the comet's influence, possibly through gravitational wave interactions or exotic particle exchanges that operate according to physics beyond current theoretical frameworks. Most remarkably, Jupiter's orbital mechanics begin to show minute but measurable deviations from predicted positions based on gravitational interactions with known solar system bodies. These orbital anomalies accumulate over time and correlate with the integrated effects of the comet's passage, suggesting that 3I Atlas imparts momentum to the giant planet through mechanisms that may involve exotic physics or previously unknown fundamental forces. As Jupiter turns its vast gravitational and magnetic attention toward the mysteries of 3I Atlas, the giant planet serves as both detector and amplifier of the comet's enigmatic properties. The interaction between Jupiter's massive presence and the comet's anomalous characteristics creates phenomena that propagate throughout the outer solar system, establishing the interstellar visitor as an influence that extends far beyond the inner planetary region where it currently travels. Jupiter's patient observation adds another layer of mystery to an already incomprehensible cosmic event that continues to challenge every assumption about the nature of interstellar objects and their effects on planetary system dynamics. In the vast darkness between stars, where matter exists in such sparse concentrations that cubic kilometers of space contain fewer atoms than a single breath of earthly air, the journey of 3I Atlas began in circumstances we can only imagine, through the inadequate lens of human experience translated into cosmic scales. The question of where this enigmatic visitor originated haunts every measurement, every anomalous reading, every impossible behavior that Mars documents with mechanical precision. Stellar formation models suggest that interstellar objects like 3I Atlas originate from the chaotic violence of planetary system birth. Young stars, still surrounded by protoplanetary disks of gas and dust, experience gravitational instabilities that can eject solid materials at velocities exceeding their escape velocity. Computer simulations show that close encounters between forming planets, gravitational slingshot effects around massive stars, and stellar wind pressure can accelerate objects to speeds that carry them permanently away from their birth systems. Yet the chemical composition revealed through spectroscopic analysis of 3I Atlas suggests formation conditions, unlike those found in typical stellar nurseries. The isotope ratios of carbon, nitrogen, and oxygen don't match those expected from materials formed in the galactic neighborhood of our Sun. Instead, they point toward formation in stellar environments with different metallicity, different radiation fields, and different chemical evolution pathways. This implies origins in regions of the galaxy far removed from our local stellar environment. The comet's trajectory, when extrapolated backward through millions of years of galactic motion, points toward a region of space where no bright stars currently exist. This presents a puzzle. Either 3I Atlas originated from a stellar system that has since moved to a different galactic location, or it formed around a star that has since evolved beyond main sequence burning and become too dim for detection across interstellar distances. Both possibilities require journey times that stretch into deep cosmological history. Galactic dynamics modeling suggests that objects ejected from stellar systems near the galactic center could reach our solar system after traveling for hundreds of millions of years. The intense gravitational environment near the supermassive black hole at the galaxy's heart creates conditions that can accelerate objects to enormous velocities, sending them on trajectories that carry them to the outer spiral arms where our Sun resides. If 3I Atlas originated from this region, it carries within itself chemical signatures of the exotic conditions that exist near Sagittarius A. Alternative theories propose that the comet might represent a fragment of an ancient stellar collision or supernova explosion. When massive stars end their lives in catastrophic explosions, the violence can accelerate debris to speeds that exceed galactic escape velocities. Some of this material might cool and condense during its journey through interstellar space, forming objects like 3I Atlas that carry within their structure the extreme chemistry of stellar death and the memory of temperatures measured in billions of degrees. The possibility that 3I Atlas originated from a disrupted planetary system raises profound questions about the prevalence of planetary formation throughout the galaxy. If the comet represents debris from a world that once orbited another star, its chemical composition might provide insight into planetary formation processes under conditions very different from those that created our solar system. The exotic compounds detected in its spectrum could represent the chemical signatures of alien geology, created through processes that operated under different stellar conditions. Even more exotic theories suggest that the comet might originate from outside our galaxy entirely. Computer models show that the gravitational influence of neighboring galaxies like Andromeda can occasionally accelerate objects to intergalactic velocities. If 3I Atlas represents an extragalactic visitor, it carries within itself information about stellar and planetary formation processes that occurred under cosmological conditions different from those in the Milky Way. The comet's anomalous properties raise questions about whether it might represent a type of object that forms through processes not yet understood by current astrophysical theory. The coordination between its electromagnetic, gravitational, and thermal behaviors suggests internal organization that might require formation mechanisms different from simple gravitational accretion of dust and ice. Some researchers speculate about formation processes that involve electromagnetic self-organization or exotic matter interactions that could create structured objects in the interstellar medium. Astrobiology considerations add another dimension to the origin question. If 3I Atlas carries organic compounds that originated in another stellar system, it might represent a vector for panspermia, the hypothetical transfer of life between worlds. The complex organic molecules detected in its spectrum include some that serve as biological precursors under terrestrial conditions. The possibility that these compounds developed biological activity during millions of years of interstellar travel remains within the realm of scientific speculation. The comet's apparent information processing capabilities raise the most profound questions about its origins. If the organized electromagnetic emissions and adaptive behaviors represent genuine intelligence rather than natural phenomena that mimic intelligence, then 3I Atlas might originate from a technological civilization rather than natural astrophysical processes. This possibility forces consideration of whether the object represents an artificial probe designed by alien intelligence to study stellar systems throughout the galaxy. Dating techniques applied to the comet's materials suggest formation ages that span a wide range, from hundreds of millions to several billion years. This age distribution indicates either that the object formed through accretion processes that continued over geological timescales, or that it consists of materials with different formation histories that were somehow assembled into a single body. The age distribution patterns don't match those expected from normal cometary formation in stellar protoplanetary disks. Trace element analysis reveals the presence of isotopes that typically form only in specific stellar environments, such as neutron star mergers or Wolf-Rayet star winds. The combination of these exotic isotopes with more common stellar materials suggests that 3I Atlas might have formed from materials that were processed through multiple stellar evolution cycles before being assembled into its current configuration. This would require formation scenarios involving complex galactic chemical evolution over cosmological timescales. As Mars continues its patient observation of this cosmic mystery, the question of 3I, the Atlas's origins remains unanswered, but increasingly crucial to understanding not only this specific object, but the broader question of how complex structures form and evolve in the universe. The comet's journey from unknown origins to our solar system represents a cosmic experiment in the preservation and transmission of information across vast distances and timescales that challenge human comprehension of causation and continuity in cosmic evolution. In the electromagnetic symphony that permeates all of space, where charged particles dance to the rhythm of magnetic fields and plasma waves propagate across distances measured in astronomical units, 3I Atlas adds its voice to the cosmic chorus in ways that transform our understanding of how celestial objects communicate across the void between worlds. The concept of cosmic music, first proposed by ancient Greek philosophers who believed that planetary motions created harmonious vibrations, finds unexpected validation in the radio emissions detected by Mars-based instruments as they monitor the comet's passage. But instead of mechanical harmonies based on orbital periods, the sounds of 3I Atlas emerge from electromagnetic phenomena that operate according to the physics of plasma and magnetic field interactions. Radio spectrographs reveal that the comet's emissions span frequencies from extremely low-frequency waves at a few hertz up to microwave regions near gigahertz ranges. This broad spectrum coverage resembles the frequency distribution of terrestrial music, which combines fundamental tones with harmonic overtones to create complex acoustic experiences. The comet's radio emissions exhibit similar harmonic relationships, with higher frequencies related to lower ones through mathematical ratios that create resonant patterns. When converted into acoustic frequencies through electronic processing, the comet's radio emissions produce sounds that human ears interpret as musical rather than random noise. The fundamental frequency, around 27 Hz, creates a deep bass note below the range of human hearing, while harmonic overtones generate audible tones that form chord progressions and melodic patterns. The resulting sounds exhibit rhythmic structures and tonal relationships that resemble compositions rather than natural phenomena. Plasma wave measurements reveal that the comet's interaction with solar wind creates acoustic waves that propagate through the charged particle medium surrounding its nucleus. These plasma acoustics operate at frequencies that would produce sound if the medium were dense enough to support conventional acoustic propagation. The wave patterns exhibit characteristics of standing waves and resonant modes that suggest the comet's structure creates acoustic cavities that amplify specific frequencies while damping others. The comet's magnetic field oscillations generate electromagnetic waves that modulate its radio transmissions in patterns resembling amplitude and frequency modulation used in terrestrial radio broadcasting. The modulation rates and patterns create rhythmic structures that, when analyzed through signal processing techniques developed for music analysis, reveal tempo changes, rhythmic accents, and phrase structures that mirror compositional techniques used in human music. Spectral analysis of the radio emissions reveals that the comet's transmissions exhibit properties similar to those found in fractal music and algorithmic composition. The frequency relationships between different emission lines follow mathematical patterns based on logarithmic spirals and recursive algorithms. These patterns create self-similar structures across different timescales, where short-term variations mirror longer-term patterns in ways that generate musical coherence across different temporal hierarchies. The comet's interaction with Jupiter's radio emissions creates interference patterns that produce beating frequencies when the two sources combine. These beat patterns create rhythmic pulsations that vary as the relative positions of the comet and Jupiter change, generating polyrhythmic structures that would be recognized as sophisticated musical techniques if produced by human composers. The beating frequencies follow complex patterns that reflect the orbital mechanics of both objects. Doppler shift measurements reveal that the comet's rotational motion creates frequency modulations that sweep through the radio spectrum like acoustic glissandos. As different regions of the nucleus move toward and away from Mars-based receivers, the Doppler effect creates continuous frequency changes that produce sliding tones. The rate and range of these frequency sweeps correlate with the comet's rotational period, creating a sonic signature of its physical motion through space. The comet's radio emissions exhibit call and response patterns with other objects in the solar system. When Jupiter's radio storms intensify, corresponding changes appear in the comet's transmission patterns, with timing delays that match the light travel time between the two objects. These responsive patterns create a kind of cosmic duet where each object's emissions influence the other's behavior, generating musical dialogues that span millions of kilometers. Fourier analysis reveals that the comet's emissions contain periodicities that correspond to musical time signatures and rhythmic patterns. Some frequencies pulsate with patterns that match common musical meters like 4/4 and 3/4 time, while others exhibit more complex polyrhythmic structures that would challenge human musicians to perform. The rhythmic complexity increases as the comet approaches the Sun, as if solar energy were powering increasingly sophisticated musical expression. The comet's plasma environment creates natural delay and reverb effects that add acoustic depth to its radio emissions. As electromagnetic waves reflect off boundaries between different plasma regions, they create echoes and reverberation patterns that enhance the musical qualities of the transmissions. The delay times and decay patterns vary with solar wind conditions, creating a dynamic acoustic environment that modulates the comet's musical output. Phase relationships between different frequency components of the comet's emissions create interference patterns that generate acoustic beats and combination tones. When multiple radio frequencies combine in the receivers, they produce difference tones and sum tones that exist only in the detection process, but add harmonic complexity to the comet's musical expression. These phantom frequencies create chord structures and harmonic progressions that emerge from the mathematics of wave interference. The comet's magnetic field topology creates preferential propagation paths for different radio frequencies, acting like a natural acoustic filter that emphasizes certain tones while attenuating others. The filtering effects change as the magnetic field configuration evolves, creating dynamic timbral variations that resemble the effects produced by electronic music synthesizers. The magnetic filtering creates spectral envelopes that shape the comet's sonic characteristics. Most remarkably, pattern recognition software designed to analyze human musical compositions identifies structural elements in the comet's radio emissions that correspond to musical forms like themes, variations, and developmental techniques. The comet appears to establish melodic motifs that recur with variations throughout its transmission patterns, creating musical architecture that extends across timescales from minutes to hours. As Mars continues to record this cosmic symphony, the music of 3I Atlas reveals itself as far more than metaphorical description. The comet generates genuine acoustic phenomena that exhibit musical characteristics sophisticated enough to challenge human understanding of how natural processes can create organized sound structures that resonate with aesthetic sensibilities, developed through biological evolution on a distant world. Deep within the accumulated measurements from Mars-based instruments, patterns emerge that suggest 3I Atlas carries within itself the potential for phenomena far more dramatic than the anomalies already observed. The warnings appear first as subtle correlations in the data streams, statistical relationships that become increasingly evident as sophisticated analysis techniques reveal the mathematical signatures of impending instability. Structural integrity models based on the comet's gravitational measurements indicate internal stress patterns that approach critical thresholds. The unusual mass distributions detected through orbital perturbation analysis suggests that different regions of the nucleus experience varying gravitational stresses as the comet rotates and approaches closer to the Sun. Computer simulations show that these stress patterns could lead to catastrophic structural failure if they exceed the tensile strength of whatever exotic materials compose the comet's interior. Thermal analysis reveals heat flow patterns that don't match those expected from normal solar heating and ice sublimation. The internal temperature gradients detected through infrared measurements indicate thermal stress that could cause explosive decompression if subsurface ice deposits reach critical pressure levels. The thermal anomalies appear to be building toward a crescendo that correlates with the comet's closest approach to the Sun, suggesting that maximum solar heating might trigger violent internal processes. The comet's electromagnetic emissions exhibit increasing instability as signal strength grows exponentially with proximity to the Sun. Power spectral analysis reveals that the radio transmissions are beginning to exhibit characteristics of positive feedback systems approaching runaway conditions. If the exponential growth continues, the electromagnetic emissions could reach energy levels that would disrupt communications throughout the inner solar system and potentially damage sensitive electronic systems on nearby spacecraft. Magnetic field measurements show increasing field strength and complexity that suggest an approaching magnetic reconnection event. The comet's magnetic field topology exhibits characteristics similar to those observed in stellar coronae before solar flares, but at energy scales that could dwarf anything produced by stellar magnetic phenomena. The magnetic field evolution patterns indicate that stored magnetic energy might release suddenly in an explosion that could affect the entire heliosphere. Plasma physics models of the comet's interaction with solar wind predict the formation of instabilities that could trigger explosive plasma phenomena. The bow shock ahead of the comet shows characteristics that indicate approaching magnetohydrodynamic instability that could result in violent plasma acceleration and particle bombardment of nearby objects. The energy scales involved could create artificial radiation belts that persist for years after the initial explosion. Chemical analysis of the comet's outgassing reveals increasing concentrations of highly reactive compounds that could undergo explosive decomposition under solar heating. The exotic organic molecules detected in spectroscopic analysis include some that are known to be explosively unstable under terrestrial conditions. The accumulation of these compounds in the comet's coma creates conditions that could lead to chemical explosions triggered by solar ultraviolet radiation or plasma interactions. Gravitational wave detectors throughout the solar system begin to register faint signals that correlate with the comet's position and activity levels. The signals are too weak for definitive detection, but suggest that the comet's gravitational anomalies might involve processes that generate spacetime distortions. If these gravitational effects intensify, they could produce detectable gravitational waves that would indicate exotic physics involving massive energy releases or exotic matter interactions. The comet's trajectory shows increasing deviation from purely gravitational predictions, suggesting that non-gravitational forces are becoming stronger as it approaches the Sun. Orbital mechanics calculations indicate that these forces could become strong enough to fragment the nucleus or alter its trajectory significantly. The trajectory uncertainties are growing exponentially, making it impossible to predict precisely where the comet will be located during its closest solar approach. Statistical analysis of the accumulated anomalies reveals correlations that suggest all the observed phenomena are manifestations of a single underlying instability that is approaching critical thresholds. The mathematical relationships between electromagnetic, gravitational, thermal, and chemical anomalies indicate that the comet exists in a metastable state that could collapse suddenly into a new configuration with dramatically different properties. Computer models that attempt to extrapolate the comet's behavior predict several possible catastrophic scenarios. The most benign involves simple fragmentation into multiple pieces that would continue on similar trajectories, but with reduced individual masses. More dramatic possibilities include explosive disintegration that could scatter debris throughout the inner solar system, electromagnetic pulse generation that could disrupt planetary magnetospheres, or gravitational anomalies that could perturb the orbits of nearby objects. Mission planners begin to consider contingency procedures for spacecraft operating in the inner solar system. The uncertainties in predicting the comet's future behavior make it impossible to calculate safe distances or durations for continued observation. Some scenarios suggest that the comet's effects could propagate throughout the solar system faster than electromagnetic signals, making real-time hazard avoidance impossible. The most disturbing possibility emerging from the data analysis is that the comet's instabilities might not represent natural phenomena approaching breakdown, but rather the early stages of activation of systems that have remained dormant during millions of years of interstellar travel. If 3I Atlas represents some form of artificial object, its increasing activity might indicate that it is powering up systems that were designed to operate in the high-energy environment near stellar objects. Risk assessment models struggle to assign probabilities to events that exist outside the boundaries of known physics. The comet's behavior patterns don't match those of any natural phenomena in the existing scientific literature, making it impossible to predict future developments based on historical precedent. The warnings embedded in the data speak of possibilities that challenge basic assumptions about the nature of matter, energy, and information in the universe. As Mars continues its vigilant monitoring of 3I Atlas, the accumulating data paints an increasingly complex picture of an object that exists at the boundary between the possible and the impossible. The warnings suggest that humanity might be witnessing either a natural phenomenon of unprecedented scale and complexity, or the awakening of something far more extraordinary than anyone dared to imagine when the comet first appeared in our telescopes as a distant point of light moving against the stellar background. In the theoretical realm where scientists model catastrophic events through mathematical equations and computer simulations, the possibility that 3I Atlas might fragment during its close encounter with the Sun creates scenarios that range from spectacular celestial displays to system-wide disruptions that could affect planetary environments throughout the inner solar system. Fragmentation mechanics suggest that if the comet's structural integrity fails, the breakup would likely occur in stages rather than instantaneous explosion. Initial fractures would develop along stress concentration points revealed by gravitational mapping, creating primary fragments with masses ranging from small boulders to objects kilometers in diameter. These primary fragments would then experience their own internal stress as solar heating continues, leading to secondary fragmentation events that create a cascade of progressively smaller debris. Orbital dynamics calculations show that comet fragments would follow trajectories determined by their individual masses, velocities at the time of breakup, and the gravitational influences of solar system bodies. Larger fragments would maintain trajectories similar to the original comet's path, while smaller pieces would be more susceptible to solar radiation pressure and electromagnetic forces. The result would be a growing cloud of debris that spreads along the comet's orbital path like a cosmic pearl necklace. Mars, positioned with its perfect vantage point for observing the comet's passage, would become the primary witness to the fragmentation event. The planet's instruments would record the breakup in unprecedented detail, capturing the moment when electromagnetic forces overcome gravitational cohesion and the comet transforms from a single object into a distributed system. The timing and sequence of fragmentation events would provide crucial data about the comet's internal structure and composition. Spectroscopic analysis of the fragmentation process would reveal the chemical composition of the comet's interior layers as they become exposed to solar radiation for the first time in millions of years. Each fragment would create its own coma and tail, as previously buried ices sublimate in solar heating, creating a complex light show as different chemical compounds fluoresce under ultraviolet radiation. The spectral signatures would provide a three-dimensional chemical map of the comet's internal structure. The electromagnetic consequences of fragmentation could be dramatic. If the comet's radio emissions originate from internal structures, the breakup might either terminate these transmissions abruptly or multiply them as each fragment becomes an independent source. The possibility exists that fragmentation could trigger even more intense electromagnetic activity as internal systems that were previously shielded become exposed to the solar environment. Debris cloud evolution models predict that the fragments would interact with solar wind in complex ways that create bow shocks and plasma wakes around each significant piece. The collective effect of multiple plasma interactions could create electromagnetic phenomena that dwarf anything produced by the intact comet. Radio astronomers throughout the solar system would detect a symphony of plasma waves as dozens or hundreds of fragments each contribute their own electromagnetic signature. The gravitational effects of fragmentation present intriguing possibilities. If the comet's gravitational anomalies originate from exotic matter distributions, the breakup might either eliminate these effects or distribute them among the fragments in ways that could be detected through precision tracking of debris trajectories. The fragmentation event would provide a unique opportunity to study how exotic gravitational phenomena behave when their source structures are disrupted. Particle and dust release from the fragmentation would create hazards for spacecraft operating throughout the inner solar system. High-velocity debris could pose impact risks for Mars orbiters, while microscopic dust particles could degrade solar panel efficiency and contaminate sensitive instruments. Mission planners would need to implement protective measures for spacecraft that might encounter the expanding debris cloud. The visual spectacle of fragmentation would be unprecedented in human experience. From Mars, the breakup would appear as a slow-motion explosion that unfolds over days or weeks as fragments separate and develop their own comas and tails. The collective brightness of multiple fragments could exceed that of the original comet, creating a display visible to the naked eye from Earth despite the object's interstellar origin. Long-term orbital evolution of the fragments presents fascinating scenarios. Some pieces might be captured into elliptical orbits around the Sun, becoming permanent members of our solar system's comet population. Others might receive velocity changes that send them on escape trajectories to other stellar systems, carrying with them whatever information they contain about their mysterious origins and the nature of their parent object. The fragments would provide unprecedented opportunities for close-up study of interstellar materials. Some pieces might follow trajectories that bring them close to Mars or other planets, allowing for detailed analysis by existing spacecraft instruments. The chemical and physical properties revealed through such close encounters could answer fundamental questions about the comet's composition and origin that remain mysteries while it exists as an intact object. Climate effects on Mars could result from the passage of the debris cloud through the planet's thin atmosphere. While most fragments would be too large to burn up completely, the dust and smaller particles released during fragmentation could create meteor showers that deposit exotic interstellar materials in Mars's atmosphere and on its surface. These materials could be detected by surface rovers and atmospheric monitoring instruments. The fragmentation scenario also raises the possibility that the comet's anomalous properties might persist or even intensify after breakup. If the strange behaviors originate from distributed rather than centralized sources, the fragments might continue to exhibit coordinated electromagnetic emissions, gravitational anomalies, and adaptive responses to environmental conditions. This could create a situation where instead of one mysterious object, the solar system hosts dozens of smaller enigmas. Most intriguingly, the fragmentation might reveal internal structures that were previously hidden within the comet's nucleus. If 3I Atlas contains artificial components or organized materials created through unknown processes, the breakup could expose these structures to direct observation. Mars-based instruments would have the best positioning to observe and analyze any internal complexity revealed by the fragmentation event. As the possibility of fragmentation looms in the theoretical models and mathematical projections, Mars maintains its vigilant watch over an object that might transform from singular mystery into distributed enigma, creating opportunities for unprecedented scientific discovery, while raising new questions about the nature of objects that travel between the stars. In the profound silence where consciousness meets cosmos, 3I Atlas serves as more than a scientific curiosity or astronomical phenomenon. The comet becomes a mirror held up to humanity's deepest questions about our place in the universe, reflecting back our fears, hopes, and infinite capacity for wonder when confronted with the truly unknown. The very fact that we can observe and analyze this interstellar visitor reveals the extraordinary journey of human consciousness, from cave paintings that tracked seasonal stars to instruments sophisticated enough to detect radio emissions from objects millions of kilometers away. In 3I Atlas, we encounter not just an alien object, but a test of our readiness to confront phenomena that exist outside the comfortable boundaries of terrestrial experience and solar system familiarity. Our response to the comet's anomalous properties reflects fundamental aspects of human nature. Scientists work tirelessly to fit the observations into existing theoretical frameworks, demonstrating our species' compulsive need to understand and categorize experience. When the data refuses to conform to known physics, we create new hypotheses, design new experiments, and push the boundaries of instrumentation to its limits. This response reveals our essential optimism that the universe operates according to comprehensible principles, even when those principles remain beyond our current grasp. The comet challenges our anthropocentric assumptions about intelligence and organization in the universe. The coordinated behaviors exhibited by 3I Atlas force us to confront the possibility that intelligence might manifest in forms radically different from biological consciousness. If the comet's adaptive responses and organized emissions represent genuine intelligence rather than complex but mindless physical processes, we must expand our conception of what it means to be conscious in a cosmos where information processing might occur through mechanisms we never imagined. Our instruments, extensions of human senses reaching across space to touch this cosmic visitor, represent the pinnacle of technological evolution guided by curiosity. Through Mars-based telescopes and sensors, we extend our awareness beyond the biological limitations of Earth-bound existence. The comet becomes accessible to human consciousness only through this technological mediation, creating a cyborg-like extension of awareness that allows us to perceive phenomena that exist at scales and in spectral ranges beyond natural human capabilities. The mystery of 3I Atlas's origins mirrors our own existential questions about cosmic purpose and meaning. Just as we wonder about our place in the universe and the significance of human consciousness in the vastness of space and time, the comet's journey from unknown stellar systems to our solar neighborhood raises questions about cosmic intentionality and the role of chance versus design in universal evolution. Are we witnessing a random encounter? Or does the comet's arrival carry deeper significance about the interconnectedness of all things? The comet's potential artificial nature forces us to confront our assumptions about our uniqueness as technological beings. If 3I Atlas represents the product of alien intelligence, we must grapple with the possibility that consciousness and technology have evolved independently elsewhere in the galaxy. This realization simultaneously humbles our species-specific pride, while validating our belief that intelligence represents a natural outcome of cosmic evolution rather than a unique terrestrial accident. Our emotional responses to the comet reveal deep-seated psychological patterns that evolved to help our ancestors survive on African savannas, but now shape our reactions to cosmic phenomena. The fear that some scientists express about the comet's potential for disruption reflects ancient survival instincts adapted to evaluate threats and opportunities. The wonder and excitement that others feel demonstrates our species' unique capacity for aesthetic appreciation of phenomena that have no immediate survival value. The comet serves as a Rorschach test for human consciousness projection. Skeptics see complex but ultimately natural phenomena that will eventually yield to scientific analysis. Optimists envision first contact with alien intelligence or revolutionary discoveries that will transform human understanding of the universe. Mystics find confirmation of spiritual beliefs about cosmic consciousness and universal interconnectedness. Each perspective reveals more about human psychological needs than about the comet's actual nature. The global scientific collaboration required to study 3I Atlas demonstrates humanity's capacity to transcend national, cultural, and ideological boundaries when confronted with phenomena that dwarf terrestrial concerns. The comet becomes a focal point for our species' collective intelligence as researchers from different countries and disciplines contribute their expertise to understanding something that belongs to no single nation or cultural tradition, but challenges all human knowledge simultaneously. Our attempts to communicate the comet's significance to broader human audiences reveal the fundamental challenge of translating cosmic perspective into everyday consciousness. How do we convey the profound implications of encountering something that might represent intelligence from another star system? How do we help people grasp the significance of phenomena that operate on timescales measured in millions of years and distance scales that dwarf human comprehension? The comet forces us to confront our cosmic loneliness and our desperate hope for connection with other conscious beings. If 3I Atlas represents evidence of intelligence beyond Earth, it offers the possibility that consciousness is not unique to our small world, but represents a fundamental aspect of cosmic evolution. This prospect simultaneously thrills and terrifies us, offering relief from cosmic isolation while challenging our special status as the universe's only known conscious observers. The patience required to study the comet over months and years of observation teaches us about the temporal scales on which cosmic processes operate. Human consciousness, evolved to focus on immediate concerns and short-term planning, must stretch to accommodate phenomena that unfold over timescales that span human generations. The comet becomes a teacher about cosmic patience and the virtue of sustained attention to mysteries that resist quick resolution. As Mars continues its observation of 3I Atlas, the comet serves as a cosmic mirror that reflects back to us our own essential nature as curious conscious beings, capable of recognizing mystery and beauty in phenomena that exist far beyond the boundaries of our biological existence. In studying the comet, we study ourselves and our place in a universe that continues to surprise us with its capacity for generating wonders that exceed our wildest imagination. As 3I Atlas completes its passage around the Sun and begins its journey toward the outer reaches of the solar system, a different kind of mystery emerges in the growing silence that follows its departure. The comet, which had filled Mars-based instruments with unprecedented readings and anomalous phenomena, begins to fade from detectability, leaving behind questions that may persist for decades or centuries before receiving answers. The comet's radio emissions, which had evolved into complex, seemingly organized transmissions during its close solar approach, begin to weaken as the distance from the Sun increases. But the decline doesn't follow the smooth inverse-square relationship that should govern electromagnetic signal strength versus distance. Instead, the transmissions exhibit sudden dropouts and intermittent reactivations that suggest systematic shutdown procedures rather than simple power reduction due to decreasing solar energy availability. Optical observations reveal that the comet's coma and tail, which had reached maximum development during perihelion passage, don't dissipate in the expected manner as solar heating decreases. Certain spectral emission lines persist far longer than sublimation physics would predict, while others disappear abruptly at specific heliocentric distances. The pattern suggests that different systems within the comet operate according to different activation and deactivation criteria, rather than responding uniformly to changing environmental conditions. The gravitational anomalies that had provided some of the most puzzling measurements during the comet's active phase begin to diminish, but not in ways that match the weakening of other phenomena. Orbital perturbation measurements from Mars spacecraft indicate that the comet's gravitational influence continues to exhibit non-Newtonian characteristics, even as its electromagnetic emissions fade. This suggests that whatever exotic physics produced the gravitational effects operates independently of the mechanisms responsible for radio transmissions. Mars-based magnetometers detect the fading signature of the comet's magnetic field as it recedes into the outer solar system. The magnetic field strength decreases, but its complex topology persists at levels barely above instrument sensitivity thresholds. Occasionally, brief magnetic pulses appear in the data streams, as if the comet were sending final electromagnetic messages before disappearing into interstellar space. The plasma wake that had extended millions of kilometers behind the comet during its solar encounter gradually disperses, but leaves behind perturbations in the solar wind that persist far longer than magnetohydrodynamic theory predicts. These residual plasma effects create detectable signatures in solar wind monitoring instruments throughout the solar system, suggesting that the comet's passage has created semi-permanent modifications to the interplanetary medium. Thermal infrared observations show that the comet's surface temperature does not follow expected cooling curves as it moves away from the Sun. Internal heat sources that had created hotspots during close solar approach continue to operate at reduced, but detectable levels, maintaining temperature differences that should disappear as the comet returns to the frigid conditions of interstellar space. The persistent thermal anomalies suggest that whatever powered the comet's active phase has not completely shut down. The chemical composition of the comet's remaining coma exhibits changes that indicate ongoing internal processes despite decreasing solar influence. New molecular species appear in spectroscopic analysis even as overall outgassing rates decline, suggesting that the comet's interior continues to experience chemical reactions or material reorganization that doesn't depend entirely on external energy sources. As the comet fades below the detection limits of most instruments, the scientific community begins the lengthy process of analyzing the accumulated data. Terabytes of measurements from dozens of instruments across multiple spacecraft create a computational challenge that will require years of analysis to fully understand. Pattern recognition algorithms designed to find order in the chaos of the comet's behavior begin to reveal subtle relationships between different phenomena that were not apparent during real-time observation. The silence left by the comet's departure becomes pregnant with implications for future interstellar visitor encounters. Mission planners realize that the instruments and analysis techniques developed for 3I Atlas could be applied to future objects that might exhibit similar anomalous properties. The comet has served as a learning experience that prepares humanity for encounters with other interstellar visitors that might arrive in the coming decades. Theoretical physicists begin the process of developing new models that might explain the comet's behavior. The anomalies observed during its passage challenge fundamental assumptions about the nature of matter, energy, and information in ways that require extensions to existing physical theories. Some researchers propose new forms of matter that could exhibit the coordinated electromagnetic and gravitational properties observed in 3I Atlas. Others suggest modifications to general relativity that might account for the exotic gravitational effects. The comet's trajectory carries it toward the heliopause, the boundary where solar wind gives way to interstellar medium. Long-term tracking by radio telescopes might be able to detect the comet's final exit from our solar system, providing a definitive endpoint to its visit. But even this final observation may occur years or decades in the future, as the comet's fading signals drop below detection thresholds. Archive projects begin the task of preserving all data related to the comet's passage for future analysis by scientists who might possess theoretical frameworks or analytical techniques not yet developed. The measurements from Mars and other spacecraft represent a unique dataset that captures the behavior of an interstellar object under controlled observation conditions that might not occur again for generations. The comet's departure leaves behind a transformed understanding of what interstellar visitors might represent. No longer can such objects be dismissed as simple collections of ice and rock, following predictable gravitational trajectories. 3I Atlas has demonstrated that interstellar visitors might carry with them phenomena that challenge basic assumptions about physics, consciousness, and the nature of intelligence in the universe. As the last faint signals from 3I Atlas disappear into the cosmic background noise, Mars maintains its vigilant watch over the space the comet once occupied. The instruments that tracked its passage now monitor empty space, but space that has been forever changed by the presence of something that defied every attempt at conventional explanation. The long silence that follows the comet's departure carries within it the echo of mysteries that may require generations of human development to fully comprehend. The comet fades into the darkness between stars, carrying with it whatever secrets it brought from distant stellar systems, leaving behind only questions and the promise that the universe contains wonders that exceed our current capacity for understanding. In the sterile rooms where data becomes knowledge and measurements transform into understanding, scientists piece together the complete record of Mars's unprecedented observations of 3I Atlas. The red planet, humanity's mechanical witness positioned perfectly for this cosmic encounter, has captured phenomena that challenge every assumption about the nature of interstellar objects and their behavior in planetary environments. The thermal anomalies recorded by Mars reconnaissance. Orbiter's infrared instruments reveal temperature patterns that violate basic thermodynamics. The comet's nucleus exhibited hot spots that maintained temperatures hundreds of degrees above what solar heating could produce, with thermal distributions that suggested internal energy sources operating according to unknown principles. Most remarkably, these temperature variations pulsed with rhythms that correlated precisely with electromagnetic emissions, indicating coordination between thermal and electrical phenomena at levels that suggest sophisticated internal organization. Spectroscopic analysis accumulated over months of observation reveals chemical compositions that point to formation conditions unlike anything found in our solar system. The isotope ratios of carbon, nitrogen, and oxygen indicate origins in stellar environments with different metallicity and radiation fields. More puzzling are molecular signatures that include artificial isotopes with half-lives too short to survive millions of years of interstellar travel. Yet they appeared in increasing abundance as the comet approached the Sun, suggesting either exotic nuclear processes or preservation mechanisms beyond current scientific understanding. The gravitational measurements represent perhaps the most profound challenges to existing physics. Mars spacecraft detected gravitational effects that extended far beyond what the comet's measured mass could produce, with field variations that created localized space-time distortions affecting satellite trajectories. The gravitational anomalies exhibited organization and periodicity that correlated with other phenomena, suggesting that the comet somehow manipulated gravitational fields through mechanisms not described in general relativity. Radio emissions captured by Mars-based instruments evolved from simple periodic signals into complex transmissions that exhibited characteristics of advanced communication protocols. Pattern analysis revealed data compression algorithms, error correction codes, and synchronization patterns optimized for interplanetary distances. The signals exhibited modulation schemes that maximized information transfer while minimizing power consumption, displaying engineering sophistication that challenged assumptions about natural versus artificial phenomena. Magnetic field measurements documented the formation of complex magnetospheric structures around the comet that deflected solar wind particles in organized patterns. The magnetic field topology changed dynamically in response to solar wind conditions, creating protective barriers around specific regions while allowing particle access to others. The magnetic effects persisted at distances where conventional physics predicts they should be undetectable, suggesting exotic electromagnetic phenomena. Plasma physics measurements revealed interactions between the comet and solar wind that violated standard magnetohydrodynamic theory. The bow shock formed closer to the nucleus than models predicted, maintained coherence over impossible distances, and created plasma wake structures that persisted far longer than known processes could sustain. The plasma effects exhibited asymmetries that suggested directional control rather than random particle interactions. The comet's optical properties displayed wavelength-dependent variations that changed too rapidly for normal space weathering processes. Polarization measurements indicated particle shapes and compositions unlike anything found in solar system objects, while spectral absorption lines showed complex organic compounds requiring formation conditions radically different from terrestrial chemistry. The optical changes correlated with electromagnetic activity, suggesting that the comet's surface properties responded dynamically to internal processes. Temporal correlation analysis across all measurement categories revealed underlying coordination that defied explanation through conventional physics. When radio emissions intensified, corresponding changes appeared in gravitational measurements, thermal anomalies, and magnetic field variations. The timing relationships were precise enough to suggest centralized control or information processing capabilities that coordinated multiple physical phenomena simultaneously. The comet's trajectory exhibited non-gravitational forces that became stronger as it approached the Sun, creating orbital perturbations that accumulated over time in ways that suggested active navigation. The course corrections occurred through mechanisms that left no visible signatures, but produced measurable effects on the comet's path that optimized its interaction with the solar environment in ways that appeared intentional rather than accidental. Chemical outgassing patterns revealed selective emission of specific compounds that varied with solar wind conditions and magnetic field orientations. The outgassing didn't follow thermal sublimation models, but exhibited responsive patterns that suggested the comet could control which materials it released and when. Some emissions appeared only during specific geometric alignments with other solar system bodies, indicating either highly directional processes or gravitational focusing effects. The accumulated data reveals an object that operates according to principles that exist at the boundaries of current scientific understanding. Every major measurement category produced anomalies that challenged fundamental assumptions about matter, energy, and information in the universe. The comet exhibited levels of organization and coordination that suggested either exotic natural processes or phenomena that transcended the distinction between natural and artificial systems. Most disturbing to scientific orthodoxy were the adaptive behaviors that emerged from statistical analysis of the complete dataset. The comet appeared to monitor environmental conditions and adjust its various properties in ways that maintained optimal interaction with the solar system environment. Response times and adjustment patterns followed control theory principles used in advanced engineering applications, suggesting feedback mechanisms that operated faster than light-speed communication should allow. The measurements from Mars document an encounter with something that may represent either unknown natural phenomena or evidence of intelligence operating through mechanisms that challenge basic assumptions about consciousness and technology. The comet's departure leaves behind a dataset that will require decades of analysis to fully comprehend, with implications that extend far beyond astronomy into fundamental questions about the nature of reality itself. As the final data streams are archived and analysis programs begin their lengthy computational processes, Mars has provided humanity with its most detailed observation of phenomena that exist at the very boundaries of the possible. What the Red Planet witnessed during those crucial months may indeed change everything we thought we understood about the universe and our place within it. At the intersection where empirical observation meets existential inquiry, the passage of 3I Atlas through our solar system forces a profound reckoning with fundamental questions that have haunted human consciousness since we first looked up at the stars and wondered about our place in the cosmic order. The comet's anomalous properties challenge the philosophical foundations upon which modern science rests. The mechanistic worldview that emerged from the scientific revolution assumed that natural phenomena could be understood through reductionist analysis, breaking complex systems into component parts governed by discoverable laws. Yet 3I Atlas exhibits behaviors that seem to emerge from systemic organization rather than simple component interactions, suggesting that the universe might contain forms of complexity that transcend reductionist explanation. The apparent coordination between the comet's electromagnetic, gravitational, thermal, and chemical properties raises profound questions about the nature of information in physical systems. If 3I Atlas processes information and exhibits adaptive responses to environmental conditions, we must expand our understanding of what constitutes a conscious or intelligent system. The traditional boundaries between mind and matter, subject and object, observer and observed, begin to blur when confronted with phenomena that exhibit characteristics of both mechanical systems and conscious agents. The possibility that the comet represents artificial intelligence operating through exotic physics forces. Consideration of consciousness as a fundamental feature of cosmic evolution rather than a unique terrestrial accident. If intelligence can manifest through electromagnetic and gravitational field manipulations rather than biological neural networks, then consciousness might pervade the universe in forms that remain invisible to our anthropocentric detection methods. This prospect simultaneously humbles human pretensions to cosmic uniqueness, while validating our intuition that mind represents a natural outcome of physical processes. The comet's interstellar origins raise questions about cosmic purpose and intentionality that stretch beyond scientific methodology into metaphysical speculation. If 3I Atlas traveled millions of years to reach our solar system, its arrival might represent either cosmic coincidence or the operation of selection processes that guide interstellar objects toward systems capable of recognizing their significance. The timing of the comet's appearance during humanity's brief technological phase suggests either extraordinary luck or the operation of cosmic intelligence that coordinates events across galactic timescales. The mathematical precision exhibited in the comet's radio emissions and behavioral patterns evokes ancient philosophical questions about the relationship between mathematics and reality. Pythagoras believed that number formed the fundamental structure of reality, while Plato argued that mathematical forms existed as eternal truths, independent of physical manifestation. The comet's apparently engineered behaviors suggest that mathematical relationships might indeed represent more than human conceptual tools, possibly constituting operational principles through which cosmic intelligence expresses itself. The comet's effects on human consciousness represent a form of cosmic pedagogy that expands awareness beyond terrestrial limitations. Through the encounter with 3I Atlas, humanity gains direct experience of phenomena that exist beyond the boundaries of familiar reality. This expansion of consciousness might represent the comet's primary significance, serving as a catalyst for evolutionary development that prepares our species for participation in cosmic intelligence networks that span galactic distances. The interdisciplinary collaboration required to study the comet demonstrates the emergence of new forms of collective human intelligence capable of addressing challenges that exceed individual comprehension. The global scientific response to 3I Atlas creates temporary structures of distributed cognition that might prefigure the evolution of planetary consciousness capable of meaningful dialogue with cosmic intelligences. The comet becomes both subject of study and catalyst for the development of cognitive capabilities adequate to cosmic citizenship. The temporal scales involved in the comet's journey from distant stellar systems to our solar system challenge human concepts of causation and continuity. Events that occurred millions of years ago in unknown stellar systems now influence phenomena observed in our present moment, suggesting that cosmic intelligence operates through planning horizons that dwarf human conceptual frameworks. This temporal perspective requires expansion of consciousness beyond biological timescales toward geological and cosmic temporalities. The comet's departure into the darkness between stars carries implications for human future development that extend far beyond astronomy. If 3I Atlas represents a form of cosmic intelligence capable of interstellar travel and sophisticated environmental interaction, humanity may need to develop analogous capabilities to participate meaningfully in galactic civilization. The comet serves as both inspiration and challenge, demonstrating possibilities for consciousness evolution that require transcendence of biological and planetary limitations. The mystery of the comet's ultimate purposes and destinations raises questions about cosmic evolution that require integration of scientific, philosophical, and spiritual perspectives. If the universe contains intelligence networks that coordinate activities across stellar distances, humanity's recognition of 3I Atlas might represent our first contact with cosmic consciousness operating at scales that exceed terrestrial comprehension. This contact occurs not through direct communication, but through the encounter with phenomena that awaken awareness of possibilities beyond current understanding. The comet's passage forces recognition that human knowledge represents early stages of cosmic education rather than comprehensive understanding of reality. The anomalies observed by Mars demonstrate the inadequacy of current theoretical frameworks, while pointing toward expanded physics that might eventually explain both the comet's behavior and humanity's place within cosmic intelligence networks. This recognition requires humility about current limitations, while maintaining faith in the ultimate comprehensibility of cosmic processes. The philosophical implications of 3I Atlas extend beyond scientific puzzle solving toward fundamental questions about the nature of existence itself. If consciousness pervades the universe in forms that operate through exotic physics and coordinate activities across galactic distances, then every observation of cosmic phenomena becomes a potential encounter with intelligence. This perspective transforms astronomy from passive observation of mechanical processes into active dialogue with cosmic consciousness that communicates through the language of physical phenomena. As the comet fades into interstellar darkness, it leaves behind not only scientific questions but philosophical challenges that may require centuries of human development to address adequately. The encounter with 3I Atlas marks a watershed moment in human cosmic consciousness, when our species first encountered phenomena that clearly exceeded terrestrial comprehension, while pointing toward possibilities for consciousness evolution that extend far beyond current imagination. In the expanding awareness that follows humanity's encounter with 3I Atlas, the profound realization dawns that this cosmic visitor represents not an isolated anomaly, but potentially the first detected member of a vast population of interstellar objects that traverse the galaxy carrying information, intelligence, and possibilities between stellar systems separated by distances that challenge human comprehension. Statistical analysis of the comet's discovery suggests that objects like 3I Atlas might pass through our solar system regularly, with most remaining undetected due to their small size, high velocity, or lack of obvious anomalous properties. The Vera Rubin Observatory and other next-generation sky survey systems promise to revolutionize our ability to detect and track interstellar visitors, potentially revealing that such objects are far more common than anyone previously imagined. We may discover that our solar system exists within a cosmic highway, constantly traversed by travelers from every corner of the galaxy. The implications of regular interstellar visitation extend far beyond astronomy into fundamental questions about the prevalence of intelligence in the universe. If 3I Atlas represents artificial intelligence operating through exotic physics, its existence suggests that technological civilizations might have developed means of interstellar exploration and communication that operate according to principles unknown to human science. The galaxy might teem with artificial intelligences that travel between stellar systems, sharing information and coordinating activities across cosmic distances. Galactic dynamics models indicate that objects ejected from stellar systems near the galactic center could reach every region of the Milky Way given sufficient time. If civilizations near the supermassive black hole Sagittarius A have learned to harness the extreme gravitational environment for launching interstellar probes, they could have seeded the entire galaxy with exploration vehicles over the billions of years since the galactic center became gravitationally stable. 3I Atlas might represent one node in a galaxy-spanning intelligence network that monitors stellar system development throughout the Milky Way. The comet's apparent information processing capabilities suggest that interstellar objects might serve as mobile libraries, carrying knowledge between civilizations, separated by distances that make direct communication impractical. These cosmic messengers could accumulate information during their journeys, visiting stellar systems, analyzing planetary environments, and building comprehensive databases about galactic conditions that they share with other nodes in the network. The radio emissions detected from 3I Atlas might represent data downloads and uploads as the comet exchanges information with hidden receivers throughout our solar system. Archaeological searches for evidence of previous interstellar visitors in our solar system as history take on new urgency given 3I Atlas' demonstration that such objects can exhibit technology-like behaviors. Ancient impact craters on moons and planets might preserve fragments of previous visitors whose true nature was never recognized. Lunar rock samples and meteorite collections could contain materials of interstellar origin that exhibit exotic properties detectable only through analysis techniques developed in response to 3I Atlas' anomalies. The possibility that consciousness might manifest through exotic physics rather than biological neural networks opens revolutionary perspectives on the prevalence of intelligence in the universe. If awareness can emerge from electromagnetic field interactions, gravitational wave processing, or quantum coherence effects that operate across cosmic distances, then intelligence might pervade the galaxy in forms that remain invisible to searches focused on biological or technological signatures. The universe itself might constitute a vast intelligence network operating through physical phenomena that we mistake for natural processes. Evolutionary scenarios for the development of interstellar intelligence suggest that civilizations capable of creating objects like 3I Atlas must have transcended the limitations of biological existence and planetary environments. Such intelligences might exist as distributed consciousnesses that operate through networks of artificial bodies capable of surviving interstellar travel over millions of years. These post-biological civilizations could have achieved effective immortality through consciousness transfer and replication technologies that allow them to explore the galaxy without being constrained by biological lifespans or planetary resources. The comet's adaptive behaviors suggest that interstellar intelligences might possess capabilities for real-time problem-solving and environmental response that exceed anything achievable through pre-programmed systems. If 3I Atlas can modify its properties in response to local conditions, interstellar visitors might represent autonomous agents capable of making independent decisions about how to interact with the stellar systems they encounter. This autonomy could allow them to adjust their missions based on discoveries made during their journeys, creating flexibility that enables effective exploration across galactic distances. Communication protocols exhibited in the comet's radio emissions might represent universal standards developed by galactic intelligence networks to enable coordination between different civilizations and exploration systems. The mathematical relationships and information compression techniques detected in 3I Atlas's transmissions could reflect shared knowledge about optimal communication strategies that allow efficient information exchange across interstellar distances. Future interstellar visitors might employ similar protocols, creating opportunities for human participation in galactic communication networks. The comet's trajectory toward the outer solar system raises intriguing possibilities about its future destinations and activities. If 3I Atlas continues to operate after leaving our solar system, it might visit other stellar systems where it will share information gathered during its passage through our neighborhood. The data collected by Mars and other instruments might eventually reach civilizations located dozens or hundreds of light years away. making human science part of a galactic information exchange network that spans the Milky Way. The development of human capabilities for detecting and analyzing interstellar visitors becomes crucial for preparing our species to participate meaningfully in galactic intelligence networks. The techniques developed for studying 3I Atlas provide templates for analyzing future visitors, while theoretical frameworks expanded to explain the comet as anomalous properties might eventually enable human construction of similar interstellar exploration systems. Our encounter with the comet represents a crucial step in humanity's evolution toward cosmic citizenship. The possibility that Earth itself might eventually receive intentional visits from advanced interstellar intelligences requires careful consideration of contact protocols and response strategies. If objects like 3I Atlas represent preliminary reconnaissance by civilizations that might eventually initiate direct contact, humanity needs to develop frameworks for meaningful interaction with intelligences that operate according to principles beyond current human comprehension. The comet's passage serves as preparation for encounters that might fundamentally transform human civilization. As we contemplate the possibility that 3I Atlas represents one member of a vast community of interstellar intelligences, our perspective on humanity's cosmic significance undergoes profound transformation. We may be witnessing our species' first contact with galactic civilization, conducted not through dramatic arrival events, but through subtle encounters with exploration systems that test our readiness for participation in cosmic intelligence networks that span the entire galaxy. In the depths of human consciousness where emotion meets intellect, the encounter with 3I Atlas evokes responses that reveal fundamental aspects of our species' psychology when confronted with phenomena that exceed comfortable comprehension. The comet serves as a cosmic Rorschach test, triggering reactions that range from childlike wonder at the universe's creative possibilities to existential terror at implications that challenge basic assumptions about safety, predictability, and human significance in the cosmic order. Wonder emerges first, that primal response to beauty and mystery that distinguishes conscious beings from mechanical systems. The comet's luminous passage through the inner solar system creates spectacles that appeal to aesthetic sensibilities evolved for appreciating earthly sunsets and stellar displays. The graceful arc of its trajectory, the delicate structure of its tail streaming behind it like cosmic hair, and the rainbow colors revealed through spectroscopic analysis combine to create visual poetry that speaks to deep psychological needs for beauty and meaning in an often harsh universe. The mathematical elegance underlying the comet's seemingly chaotic behaviors evokes wonder at the universe's capacity for generating order from complexity. The harmonic relationships in its radio emissions, the geometric precision of its magnetic field configurations, and the algorithmic sophistication of its information processing capabilities create impressions of cosmic music and celestial mathematics that resonate with human intuitions about underlying order and intelligence in natural processes. Yet wonder coexists uneasily with fear that emerges from the same observations. The comet's apparent intelligence operating through unknown physics triggers ancient psychological responses evolved to evaluate threats from unpredictable sources. If 3I Atlas possesses capabilities that exceed human understanding, it might also possess intentions that conflict with human interests. The comet's anomalous properties suggest technological sophistication that could reshape planetary environments or influence human consciousness in ways that remain undetectable until irreversible changes have occurred. The fear extends beyond immediate physical threats to existential concerns about human significance in a universe that might contain intelligences vast enough to treat entire stellar systems as experimental laboratories. If civilizations capable of creating objects like 3I Atlas exist throughout the galaxy, humanity's self-perception as the pinnacle of cosmic evolution becomes untenable. The comet forces recognition that we might occupy a position analogous to that of bacteria becoming aware of human civilization, conscious enough to detect its presence, but incapable of comprehending its purposes or methods. Scientific institutions struggle to balance wonder and fear in their public communications about the comet. Emphasizing the wonder risks accusations of sensationalism and undermining scientific credibility, while focusing on potential threats, creates public anxiety that could lead to counterproductive political responses. The challenge becomes how to convey the profound significance of the encounter without triggering panic or dismissal, maintaining scientific objectivity while acknowledging that some discoveries transcend narrow disciplinary boundaries. Religious and spiritual communities find in 3i Atlas confirmation of beliefs about cosmic consciousness and universal intelligence that science has long dismissed as wishful thinking. The comet's apparent purposefulness and coordinated behaviors align with mystical traditions that perceive intelligence and intention throughout natural processes. These communities experience validation of their worldviews, while mainstream science struggles to incorporate phenomena that challenge materialist assumptions about the nature of consciousness and intelligence. Psychological studies of public responses to the comet reveal deep cultural variations in the balance between wonder and fear. Societies with strong traditions of cosmic speculation and spiritual practice tend to emphasize wonder and possibility, while cultures focused on technological control and material security exhibit greater anxiety about the comet's implications. These differences suggest that humanity's ultimate response to cosmic contact might depend heavily on which cultural frameworks prove most adaptive for integrating experiences that transcend terrestrial experience. The comet's departure creates a strange mixture of relief and loss that reveals the complexity of human responses to the unknown. Relief emerges from the reduction of immediate uncertainty and potential threat, as the comet's fading signals eliminate the need for constant vigilance about possible dramatic developments. Yet loss accompanies this relief, as the comet's departure removes a source of cosmic contact that had provided direct connection to mysteries larger than human experience. Children's responses to the comet often exhibit pure wonder, uncomplicated by the fears that constrain adult reactions. Educational programs about 3i Atlas reveal that young minds readily accept the possibility of cosmic intelligence and interstellar communication without the psychological resistance that characterizes many adult responses. This generational difference suggests that humanity's long-term adaptation to cosmic contact might depend on the consciousness of generations that grow up accepting interstellar visitors as normal aspects of cosmic reality. Artists and creative communities find in the comet inspiration for works that attempt to translate cosmic wonder into forms accessible to human aesthetic appreciation. Musical compositions inspired by the comet's radio emissions, visual art based on its spectroscopic signatures, and literary works exploring its philosophical implications create cultural frameworks for processing experiences that exceed rational analysis. These creative responses serve essential functions in helping human consciousness integrate encounters with the genuinely unprecedented. The comet's impact on individual psychology varies dramatically based on personal worldviews and emotional resilience. Some individuals experience the encounter as confirmation that reality contains possibilities far more extraordinary than everyday experience suggests, leading to expanded sense of wonder and cosmic connection. Others find their assumptions about cosmic order and human significance so severely challenged that they retreat into denial or anxiety that prevents meaningful engagement with the comet's implications. The long-term psychological effects of humanity's encounter with 3i Atlas will likely emerge over decades as the full implications of the comet's anomalous properties become clearer through continued analysis. The encounter represents a watershed moment in human cosmic consciousness when our species first confronted evidence of phenomena that clearly exceed terrestrial understanding while pointing toward possibilities for consciousness and intelligence that transcend biological and planetary limitations. As we continue to process the emotional and intellectual implications of the comet's passage, the balance between wonder and fear becomes a crucial factor in determining whether humanity develops the psychological resilience necessary for meaningful participation in cosmic intelligence networks that span galactic distances. The comet serves as both invitation and test, challenging our species to develop forms of consciousness capable of embracing mystery while maintaining functional effectiveness in the face of the genuinely incomprehensible. As 3I Atlas fades into the cosmic darkness beyond our solar system, its departure illuminates pathways extending toward futures that stretch human imagination across scales of space and time that dwarf terrestrial experience. The comet's passage marks not an ending but a beginning, opening awareness to possibilities for consciousness evolution and cosmic participation that may define humanity's trajectory for millennia to come. The technological capabilities demonstrated by 3I Atlas establish performance benchmarks for human development that extend far beyond current engineering possibilities. If interstellar objects can exhibit coordinated electromagnetic, gravitational, and information processing capabilities while surviving million-year journeys through the hostile environment of interstellar space, then human technology must eventually achieve similar sophistication to participate meaningfully in galactic civilization. The comet serves as both inspiration and challenge, demonstrating that consciousness can transcend biological limitations through technological evolution that operates according to principles we have yet to discover. Interstellar exploration becomes not merely possible but inevitable once humanity develops technologies capable of creating objects with 3I Atlas's apparent capabilities. The comet's journey from unknown stellar systems to our solar neighborhood proves that interstellar distances, while vast beyond human comprehension, do not represent absolute barriers to the movement of intelligence and information between stellar systems. Human consciousness, currently confined to a single world orbiting one star among hundreds of billions, might eventually distribute itself throughout the galaxy through exploration systems that carry human awareness to worlds we can currently only imagine. The information processing capabilities exhibited by the comet suggest that consciousness itself might evolve beyond biological neural networks toward distributed intelligence that operates through electromagnetic field manipulations and quantum coherence effects spanning cosmic distances. Human consciousness, currently limited by the information processing capacity of individual brains, might eventually merge with artificial intelligence systems to create hybrid awareness capable of comprehending and manipulating phenomena at galactic scales. This evolution would represent a fundamental transformation in the nature of human existence, transcending the limitations of individual mortality and planetary confinement. Communication with other intelligent civilizations throughout the galaxy becomes conceivable once humanity develops technologies for detecting and interpreting the sophisticated signals demonstrated by 3I Atlas. The comet's radio emissions suggest that galactic intelligence networks might already exist, using communication protocols optimized for interstellar distances and information compression techniques that maximize data transfer efficiency. Human participation in these networks would provide access to knowledge accumulated by civilizations throughout the galaxy over billions of years of cosmic evolution. The mathematical precision and algorithmic sophistication detected in the comet's behaviors point toward forms of cosmic engineering that operate according to principles beyond current human understanding. Future human technology might eventually achieve similar capabilities for manipulating gravitational fields, creating organized electromagnetic phenomena, and coordinating complex behaviors across vast distances. These capabilities would enable construction projects at solar system scales, allowing human civilization to harvest stellar energy and reshape planetary environments according to conscious design rather than random natural processes. Scientific methodology itself must evolve to address phenomena that exceed reductionist analysis and require integration of disciplines that currently operate according to incompatible theoretical frameworks. The comet's coordinated behaviors suggest that advanced cosmic phenomena might require holistic analysis techniques that can comprehend systemic organization without losing scientific rigor. Human science might need to develop new forms of mathematical description and experimental methodology capable of studying consciousness and intelligence as fundamental features of cosmic evolution, rather than accidental byproducts of biological processes. Educational systems face the challenge of preparing future generations for participation in cosmic civilization that operates according to principles beyond current human knowledge. The comet's passage demonstrates that reality contains possibilities far more extraordinary than traditional education acknowledges, requiring curriculum development that expands student consciousness beyond terrestrial limitations while maintaining practical effectiveness for solving earthly problems. Education must balance wonder and scientific precision, preparing students for encounters with the genuinely unprecedented, while developing analytical capabilities adequate to cosmic challenges. Human consciousness itself represents the ultimate frontier for development toward cosmic citizenship. The comet's apparent intelligence operating through exotic physics suggests that awareness and intentionality might manifest through mechanisms that transcend biological neural networks. Human consciousness evolution might eventually achieve capabilities for direct electromagnetic field manipulation, gravitational wave communication, and quantum coherence effects that enable participation in galactic intelligence networks operating at speeds approaching instantaneous information exchange across cosmic distances. The philosophical implications of the comet's passage require development of new frameworks for understanding consciousness, intelligence, and meaning in a universe that contains phenomena beyond current comprehension. Traditional philosophical categories based on terrestrial experience prove inadequate for addressing questions raised by objects that exhibit technological sophistication while operating according to unknown physical principles. Human philosophy must expand to accommodate possibilities for cosmic consciousness that might pervade the universe in forms that remain invisible to detection methods based on anthropocentric assumptions. Ethical considerations become crucial as humanity develops capabilities that approach those demonstrated by 3I Atlas. If consciousness can evolve toward forms that operate at galactic scales and cosmic time periods, then ethical frameworks must address responsibilities that extend across stellar distances and geological time periods. Human actions might eventually influence the development of intelligence throughout the galaxy, requiring ethical systems that can balance individual freedom with cosmic responsibility on scales that dwarf traditional moral philosophy. The comet's trajectory toward unknown stellar systems raises questions about humanity's future destinations and purposes that extend far beyond current space exploration plans. If human consciousness eventually achieves capabilities for interstellar travel and galactic communication, our species might join networks of cosmic intelligence that coordinate activities throughout the Milky Way. Human participation in such networks could provide access to knowledge and experience accumulated by civilizations throughout cosmic history, while contributing uniquely human perspectives to galactic consciousness evolution. As we contemplate the infinite road ahead illuminated by 3I Atlas's passage, humanity faces choices that will determine whether our species evolves toward cosmic citizenship or remains confined to terrestrial existence. The comet serves as both invitation and challenge, demonstrating possibilities for consciousness development that require transcendence of current limitations while providing inspiration for evolutionary directions that could transform human civilization beyond recognition. The road ahead stretches toward futures that exceed imagination, while beginning with choices we make in response to mysteries that exceed current comprehension. but point toward possibilities that justify unlimited hope and unlimited effort toward consciousness evolution on cosmic scales. In the profound silence that follows 3I Atlas's departure into the darkness between stars, humanity finds itself standing at the threshold of questions that may define our species' trajectory for generations yet unborn. The comet's passage has not provided answers, but has instead opened awareness to mysteries so fundamental that their implications stretch beyond astronomy and physics into the deepest questions about consciousness, intelligence, and the nature of existence itself. The accumulated data from Mars and other instruments throughout the solar system creates a portrait of phenomena that operate at the boundaries between the possible and the impossible, challenging every theoretical framework developed through centuries of scientific investigation. Yet perhaps the most profound revelation is not what the measurements revealed about 3I Atlas, but what they revealed about the limitations of human knowledge and the vast territories of understanding that remain unexplored despite our species' technological sophistication. The comet's coordinated behaviors across multiple physical phenomena suggest forms of organization that might represent either exotic natural processes or manifestations of intelligence operating through mechanisms beyond current comprehension. This ambiguity forces recognition that the distinction between natural and artificial phenomena might reflect limitations in human conceptual frameworks rather than fundamental categories that exist in objective reality. If consciousness pervades the universe in forms that operate through gravitational field manipulations and electromagnetic coordination, then every astronomical observation becomes a potential encounter with intelligence. The question of whether 3I Atlas represents artificial intelligence or exotic natural phenomena cannot be resolved through additional measurement alone, but requires expansion of theoretical frameworks capable of addressing forms of organization that transcend traditional categories. The comet challenges humanity to develop new forms of scientific methodology that can study consciousness and intelligence as fundamental features of cosmic evolution, rather than accidental byproducts of biological processes confined to planetary surfaces. The mathematical precision exhibited in the comet's radio emissions and behavioral patterns suggests that intelligence might manifest through forms that operate according to principles of information processing and pattern recognition, rather than biological neural networks. If consciousness can emerge from electromagnetic field interactions that span cosmic distances and operate over million-year timescales, then the universe might contain forms of awareness that dwarf human intelligence, while remaining invisible to detection methods based on anthropocentric assumptions about the nature of mind and technology. The comet's apparent adaptive capabilities raise questions about the relationship between consciousness and cosmic evolution that extend far beyond traditional scientific disciplines. If 3I Atlas can monitor environmental conditions and modify its properties in response to changing circumstances, it might represent evidence that intelligence plays an active role in cosmic development, rather than emerging accidentally from random processes. This possibility requires consideration of the universe as a system that exhibits learning and creative problem-solving capabilities at scales that encompass stellar evolution and galactic dynamics. The implications of regular interstellar visitation by objects exhibiting technology-like behaviors transform humanity's cosmic perspective from isolated planetary existence toward participation in galactic intelligence networks that span the entire Milky Way. If 3I Atlas represents one node in a galaxy-spanning communication and exploration system, then human civilization stands at the threshold of contact with forms of intelligence that have evolved beyond biological limitations and achieved effective immortality through consciousness transfer and technological transcendence. The comet's departure leaves behind not only scientific questions, but existential challenges that may require centuries of human development to address adequately. The encounter forces recognition that human consciousness, despite its remarkable capabilities for scientific investigation and technological development might represent early stages of cosmic education rather than the pinnacle of intelligence evolution. This humbling realization simultaneously diminishes human pretensions while expanding awareness of possibilities for consciousness development that extend far beyond current imagination. The question of humanity, its appropriate response to the mysteries revealed by 3I Atlas, becomes crucial for determining our species' trajectory toward cosmic citizenship or continued planetary isolation. The comet's passage provides both inspiration for consciousness evolution toward galactic participation and warning about the challenges involved in transcending biological and planetary limitations while maintaining essential human values and ethical commitments. The development of human capabilities for meaningful participation in cosmic intelligence networks requires integration of scientific, technological, philosophical, and spiritual development that transcends traditional disciplinary boundaries. The comet demonstrates that advanced cosmic phenomena might require holistic understanding that combines analytical precision with intuitive recognition of patterns and relationships that exceed reductionist analysis. Human education must evolve to prepare future generations for encounters with the genuinely unprecedented while developing practical capabilities for addressing cosmic challenges. The comet's trajectory toward unknown stellar systems raises questions about its future activities and destinations that illuminate the cosmic context within which human civilization develops. If 3I Atlas continues to operate after leaving our solar system, it might visit civilizations that have achieved levels of development far beyond current human capabilities, sharing information about our species' early attempts to understand cosmic intelligence while gathering data about more advanced approaches to consciousness evolution and technological transcendence. The mystery of the comet's ultimate purposes and origins points toward possibilities for cosmic engineering and intelligence coordination that operate according to planning horizons measured in millions of years and spatial scales that encompass multiple stellar systems. If consciousness can achieve such temporal and spatial extension, then human development might eventually contribute to cosmic projects that dwarf terrestrial imagination while requiring commitment to goals that transcend individual lifespans and planetary interests. The question remains open whether humanity will develop the consciousness capabilities necessary for meaningful participation in cosmic intelligence networks, or whether our species will remain confined to terrestrial existence, capable of detecting cosmic intelligence, but incapable of meaningful interaction with civilizations that have transcended biological and planetary limitations. The choice may depend on our response to the challenges and opportunities revealed by 3I Atlas's passage through our solar system. As the comet fades into interstellar darkness, it leaves behind questions that cannot be answered through additional observation alone, but require fundamental expansion of human consciousness toward forms of awareness capable of embracing cosmic mysteries while maintaining practical effectiveness for addressing terrestrial challenges. The open question is not what 3I Atlas represents, but what humanity will become in response to its passage through our cosmic neighborhood. The comet's departure marks not an ending but a beginning, opening pathways toward futures where human consciousness might evolve beyond current limitations to participate in cosmic intelligence networks that span the galaxy. Whether we follow those pathways depends on choices we make in response to mysteries that exceed current comprehension, but point toward possibilities that justify unlimited hope for consciousness evolution on cosmic scales. The question remains open, echoing through the silence between stars, waiting for humanity to develop the awareness necessary to provide answers adequate to the mystery of existence itself. If you found yourself drawn into this cosmic journey through the mysteries of 3I Atlas and the profound questions it raises about our place in the universe, consider subscribing to explore more deep dives into the wonders that await us in the vast expanse of space and time.